Hello students, welcome to the class. So today we'll start our new chapter in the day 5 of this JEE 40 days crash course, and this chapter would be chemical bonding and molecular structure. So please join the class as soon as possible. So first we will do the theory part, and then after we will move on to the questions as well. So I would request all of you to quickly join this class. So today we will see up to the part which is related to your hybridization. So we'll start a part of the hybridization today. Then we will cover the rest of the part of this theory of chemical bonding and molecular structure in the day 6, which is on Monday. So please join the class as soon as possible. Hello Harsha Rao. Hello Rathod. So please join the class. So if you have a doubt from the previous class, you can ask it here. Any doubt from yesterday's class or any other class that I have covered? So basically we have covered 2 chapters till now, which is some basic concepts of chemistry, and then we have looked upon the atomic structure chapter. So today is our 3rd chapter on the day 5. Okay, so I will begin my class at 4:05. So those who are going to join the class, please attend it. Okay, so we will talk about the banana bonding thing in the P block element chapter. Okay, and about MOT. So MOT will be covered tomorrow. Today we will move up to the hybridization only. Got it? So banana bonding will be taught in your P block, where we will look upon the boron family. So there we will cover this banana bonding. Got it? So please join the class. Okay. So it is already 4:05. So now we shall begin our class. So this is our disclaimer. Now, if I talk about the analysis of this chapter, so there is a very high percentage of the weightage from the chapter chemical bonding and molecular structure. So 3 chapters are very important for your inorganic part, which includes chemical bonding and molecular structure. Then we have D and F block, and then we have coordination. So if you are not willing to cover the whole inorganic, I will suggest you to cover these 3 parts at least, and believe me, it will give you a wholesome amount of number in your JEE exams. Yes, so each concept will be covered in today's class, and some part of this theory will be covered in tomorrow's class. Now, if I look upon the important topics of this chapter, then the first which is seen as an important part is your MOT. So recently questions are asked in a numerous amount from the MOT part, which is molecular orbital theory. Got it? Then second part which is important is your hybridization and shape. So shape and hybridization is, as you know, is a popular topic from this valence bond theory. Questions are asked in a number of times for the case of finding the shape and geometry and all. And the third thing is the hybridization, Vesper theory. So 3 things that are important for this chapter are, first of all, molecular orbital theory, then we have this Vesper theory, and third we have this hybridization. So if you look upon the analysis, so we can see questions from MOT in both year 2023 and 2022. Then we can see questions from Vesper in 2022 and 2021. Talking about hybridization, so hybridization is been asked in 2022 and 2021. Now the fourth topic which is important is your bond parameter, which includes the bond polarity and your bond length, bond angle and all. So what are the 4 important topics? So one more topic is now added here. So first is the molecular orbital theory, second is the Vesper theory, third is the hybridization, and fourth is your bond parameter. Now, if I talk about the year 2020, the questions between 2020 and 2017, then again you can see questions in each year from the topic molecular orbital theory. You can see it in 2020, 2019, 18 and 17 as well. Now, what are the things that we will cover today? So first of all, we will start with the Kovalev-Lewis approach. Now, talking about the Kovalev-Lewis approach, the most important point which is related to this Kovalev-Lewis approach is your octet rule. It says that every element has a tendency to complete its octet or keep 8 electrons in its valence shell. So there are some exceptions to it. We have hydrogen and helium, which has a tendency to keep 2 electrons. Apart from that, we have other elements which are capable of showing hypovalency or hypervalency. Now, what is hypervalency and hypovalency? So in hypervalency, the number of electrons is greater than 8. Okay, and in hypovalency, the number of electron is less than 8. Now, how do you determine the number of electrons in a given molecule for a specific atom? So for that, we use the Lewis structure, and that Lewis structure is drawn with the help of Lewis symbol of different elements. Now, what is a Lewis symbol? It is written in the form of the representation of the element with its short form along with dots around it to represent the valence electrons or the number of valence electron. Now, as I said you that some elements do show hypervalency and hypovalency. So that is included in the limitations of octet rule. Now, in accordance to this rule, the first limitation that we will see is the shape of the molecule cannot be predicted from the octet rule. It was later on being found out with the help of whisper theory, VBT and your MOT. So, octet rule says nothing about the shape of the molecule. So, this is the first limitation. Second, we cannot compare the stability of molecule with the help of this octet rule. Then next, we have some exceptions to this octet rule as well. Now, what are these exceptions? So, we have a set of molecules here which are electron deficient compounds. So, can you say me why these elements are electron deficient or these compounds are electron deficient? Suppose if I tell you that what is the electron deficiency in case of BF3, means what is the count of electron, valence electron for boron in BF3? Is it following the octet rule? Is it having 8 electrons or not? So you can answer it in the chat box or in the comment section. So is it boron is completing its valency in the BF3 molecule? If not, then what is the number of electron it has? You can similarly tell it for BeCl2 and AlCl3. Anyone who is willing to give the answer for this question? Again, I am repeating it. So questions were asked in a different way also in your exams. Suppose if someone asks you what is the number of hypovalent compound given in the list of a certain number of compounds, then you can just list it out. Now my question is that what is the number of electrons for beryllium in BeCl2, for boron in BF3 and for AlCl3 aluminium? What is the total number of valence electron for these elements in the particular compound? Is it having an electron count less than 8? So for that, first you try to draw the Lewis structure. There you will clearly see that these elements are showing electron deficiency. So if I take the case of BeCl2, so what is the total number of valence electron for the beryllium? What is the atomic number and what is the total number of valence electron for the beryllium? Again, I am repeating my question. What is the total number of valence electron for beryllium? So many of you are attending the class, so I will encourage. Yes. So yeah, so I'm seeing one answer. It is 233. Okay. Yes, so for beryllium, the number of valence electron is 2. Now, beryllium shares its 2 electron with 2 chlorine atoms. Now, these 2 chlorine atoms will also exchange 1 electron with respect to the electron of beryllium. What will happen as a result of it? It will get 2 more electrons from chlorine. The boron will get 2 more electrons from chlorine, and therefore the total number of valence electron is 4 in the case of BCl2 for beryllium. Hence, since it is less than 8, therefore your beryllium is electron deficient. Similarly, if you take the case of the boron in BF3, so 3 electrons are already there in the valence shell of the boron and 3 are coming from the fluorine, which will count to a total of 6 electrons for boron. Again, it has an incomplete octet, means there is a void of 2 electrons, and same can be said about AlCl3 as well. So therefore, in BCl2, beryllium is having 4 valence electrons after getting electrons from chlorine. Then boron is having 6 valence electron after getting electrons or after sharing electrons with fluorine, and your aluminium is having 6 electron after sharing electrons with chlorine. Now in all of these compounds, all 3 elements are electron deficient. Next we have some hypervalent compound. How they are hypervalent? It's very simple. You simply draw the Lewis structure of your PCl5. Suppose we take the case of PCl5. So what will be the valency of your phosphorus? It is 5. Again, it is making 5 bonds with chlorine. Now, 5 was the initial count of valence electron phosphorus, and 5 will come from chlorine due to the monovalency of chlorine, because chlorine needs only 1 electron, so it will be sharing 1 electron with the phosphorus. As a result of it, 5 from phosphorus and 5 coming from chlorine, the total count of valence electron for phosphorus will be 10, and that is simply greater than 8. So this is the case of hypervalent compound or electron rich species. Is it correct? Are you getting my point? It's very simple to do. Just try to draw the Lewis structure of PCl5 by yourself. Then you will clearly get the idea why I am saying that your PCl5 will have a case of hypervalent phosphorus. Yes. Next what we have? SF6. So if you take the case of sulfur, the number of valence electron is 6. Yes, you need to know the number of valence electron. Now, this 6 electrons will be shared with the 6 fluorine atoms surrounding the sulfur atom. As a result of it, there will be 1 electron sharing, and total 12 electrons will be now there for the sulfur, because 6 are coming from sulfur itself and 6 are coming from the fluorine. Now again, this will give you a total of 12 electrons, which is greater than 8. So this is also the case of hypervalency. And lastly, we have IF7. Now, what is iodine? What is the group of iodine? Suppose if I ask you in which group your iodine lies, whether it is a halogen or is it your chalcogen or alkali metal or alkaline earth metals. So what is the group of your iodine? Anyone who is willing to answer it? So which group does iodine belongs to? So I would encourage all of you to please comment your problems and the questions that I am asking, the answers of it in the comment section. So what is the group of iodine in which it belongs? Is it a chalcogen or a halogen or alkali? Yes, it is halogen. Anyone more? Any more options? Yes, it is belonging to group 17, which is halogen. Now, if it is belonging to group 17 or halogen, means it will need only 1 electron to complete its octet. And the total number of valence electron in every halogen is 7. Suppose if you take the chlorine or you take the bromine, fluorine or iodine, each of these elements have 7 electrons in their valence shell. Right? Now if this is true, then these 7 electrons are available for bonding with or doing an electron share with the fluorine. So these 7 electrons of iodine will do a electron share of 1 with each fluorine atom, and therefore 7 fluorine atoms will donate 1 electron each, and hence the total count of valence electron on iodine will be 14, 7 from itself and 7 from 7 fluorine atoms. Now if I ask you, why in these 3 compounds PCl5, SF6 and IF7 the surrounding atoms are donating only 1 electron? What is the reason behind it? Because each of these are monovalent compound, because these are halogens. Suppose you take the case of PCl5, the surrounding atom is chlorine, which is a halogen atom or monovalent in nature. Again in SF6 the fluorine is monovalent, and your IF7 is also monovalent fluorine atom. Clear to you? Next we have the third exception to the octet rule, which is for the noble gas. So if you consider a noble gas, then from our octet point of view, it should not have been involved in the formation of bond, right? Now why I am saying this, why your noble gas are not a good selection according to the octet rule for making compounds or for forming bonds? Is there any reason for it? Because it has 8 electrons in its valence shell. After that also, here you can see that we have multiple compounds of your noble gases. Suppose we can see XeF2. So your xenon is a noble gas. Hence this will be considered as your element having a complete octet, but still it is making what? It is making a bond and increasing its electron count by 2, giving a total count of 10 valence electron for xenon. Similarly for XeF6, the total count of electron is 14. For XeF4 it is what? 12. For KrF2 it is again 10. So don't worry if you are facing any issues in this class or any other class. So if you have a doubt, you can just come to our website and ask questions there in the doubt clearing session, or if you are getting problem in between the class, you can just comment it down and I will try my best to solve that problem. Okay, so don't worry if you are having any difficulty. So we will go through each of the chapter of your 11th and 12th of your JEE class, and we will try to do the PYQs as well. And to do your preparation in a better way, you can just move on to the DPP. So you need not have to take tension. Okay. Now coming on to the fourth one, we have odd electron molecules. So some of the molecules are capable of forming or having odd number of electrons. So we have the example of NO, NO2, O2 minus and O3. If you draw the Lewis structure of each of these, then they will have odd number of valence electron, which is again violating your octet rule. So I will suggest all of you to please at least fill the form of this upcoming session of your JEE exam, because in this upcoming session of January there is a higher chance of you getting selected, because the percentile will not go to a higher stage. So it is seen in the previous trends also that students who are working hard for the first session have a greater chance of getting admitted to or qualifying the JEE exams. Okay, so don't worry, try to give the exam in this session only with your full effort. Now coming on to the next one, helium 2 plus, then H2 plus, O2, NO, NO2, ClO2 are some example of stable molecules which have odd electron bonds. Means bond are formed by unusual sharing of the electrons. So we have seen in the case of octet, if you consider the octet way of drawing the compound or the Lewis structure of compound, you will notice that only 1-on-1 sharing is possible or 2-on-2 sharing is possible. That is only possible in the case of your what? In the case of your octet, or in the case of a Lewis symbol, right? But or the Lewis structure. But it is seen that when you will move on to the compounds which are of complex structure, there is a case that electron is formed by the sharing of one electron only. Okay, means two electrons were not needed to make a bond, or you will see that three electrons are involved in making bond. So why I am saying it, because general idea behind bond making is that there is a even count for making bonds, right? So if you consider a single bond, two electrons are involved. If you consider a double bond, four electrons are involved. But it was seen later on that some of the bonds are formed with odd number of electrons like 1, 3, 5 or 7. Got it? Any issues in this? So we will talk about these molecules in the upcoming sessions. Any doubt in this? Now we will talk about some of the characteristics of ionic bond. So we know that ionic bonds are formed by the species of opposite charge due to the electrostatic force of attraction between them. You know it very well. Now it is generally formed between those atoms which have high difference in their electronegativity, and in those molecules there is almost a complete transfer of electrons. Now if we take an example, ionic bond, as I said, is formed by the complete transfer of electrons from one atom to another. If we take NaCl, suppose, so NaCl, the sodium has 11 electrons and chlorine has 17 electrons. Now if I write the electronic configuration, it will be 281 for sodium and 287 for chlorine. Yes, I will try to keep the upcoming topics as independent as possible, but at least you should have an idea of the basic chemistry like your atomic number, electronic configuration and all. So this thing must be in your I would say knowledge book to keep a track of my lecture. Now what will happen? One valence electron of sodium can be transferred onto chlorine and we can get two ions. First is Na plus ion and the second one is Cl minus ion. Now these two ions are having opposite charges on them and they will attract each other and join hands together due to electrostatic force of attraction to form the NaCl, what? NaCl solid. Now remember one very important point, that ionic bonds are non-directional and are also known as electrovalent bond or polar bonds. What did I say? Ionic bond are non-directional, means the position of chlorine is not certain. Suppose if you take NaCl, then Cl can be on any side of the sodium, because it makes no sense that your chlorine can be oriented in one direction only, because two circles are there, they can be in any orientation with respect to each other. Easy to get? So you must at least remember the statement that ionic bonds are non-directional in nature. Now moving on further. Now we will see the types of covalent bond. So just wait for a while. I will be there in a minute. Now moving on to the types of covalent bond. So covalent bond can be of the following two types. First is non-polar covalent bond. So basically, if two similar kind of groups are attached to each other by a single bond, then it will result in equal electronegativity. Now that group can be a single atom or it can be a group of atom at the same time. So both things are possible. What did I say? I said that if two similar type of groups are attached to each other. Now they are similar in every respect, with respect to your orientation, with respect to your electronic configuration and all. So if two similar type of I would say groups are attached to each other, then it will result in non-polar covalent bond. Got it? Now we can take it for example atoms also. So if you take the example of hydrogen molecule, so they are formed by the combination of two hydrogen atoms. Since these two hydrogen atoms are, as you know, identical to each other, therefore it will be a non-polar molecule. Got it? Now moving on to the next, if we take one more example, suppose we have two different same groups like CH3 and CH3 attached in case of ethane, right? If that is true, what will happen? Okay, sorry for the interruption. So as I said that if similar to if similar type of two groups are attached to each other like your CH3 and CH3 in case of ethane, then it will result in a non-polar covalent bond. So we have examples here of homonuclear atoms like H2, Cl2, F2 and Br2. So in this, two homonuclear atoms are attached by a single bond or multiple bond. Next we have polar covalent bonds. So these are formed when two groups of different electronegativity are attached to each other. As a result of this, there will be a partial ionic character and a partial covalent character in that particular molecule. Now, next we can have an example of water. So here water, if you take the case of water, then two hydrogen atoms are attached to oxygen, means the connectivity of group is somewhat different. Similarly, in case of hydrogen chloride, which is HCl, the two groups are different. One is hydrogen, the other one is chlorine. That will again result in a polar covalent bond. So do you have a doubt till now, anyone? So this theory is important for your question part. So just be tuned to here. Okay. Anyone who has a doubt till now regarding this? Okay. Now we shall move forward. It is seen that greater is the difference in electronegativity, higher is the polarity of that bond or higher the polar nature of that particular molecule. So rather than taking HCl, what else can we take rather than chlorine to make a much more polar molecule? Is there any element in your mind? So again I am repeating my question. So in case of your HCl, what else atom can you take in place of your chlorine to make a more polar molecule? So obviously you can take the case of fluorine. So if you take HF here, then that would result in a much more polar bond as compared to your chlorine, because hydrogen and fluorine have a greater electronegativity difference as compared to hydrogen and chlorine, because fluorine is the most electronegative element in your whole periodic table. Yes, very good. The correct answer is HF. Now, here is a series to show the electronegativity difference between different elements which are non-metallic in nature. So fluorine is the most electronegative one, having electronegativity of 4. Then we have oxygen having an electronegativity of 3.5. Then chlorine and nitrogen are almost equally electronegative with electronegativity of 3.0. Then comes your bromine with 2.8. Then sulfur, carbon and iodine have almost the same electronegativity, which is 2.5, and lastly we have hydrogen, which is having an electronegativity of 2.1. Easy to get. Now we will move on to a very important part of this lecture, which is calculation of percentage ionic character. It is seen that any compound that you take, right, any compound that you take will be never a completely ionic or a completely covalent compound. There is always some percentage of ionic character and covalent character in any given molecule. Now, how do you calculate the ionic character? Now, this is only possible in case of polar bond present there in that particular compound. If there is no polar bond at all, then it will not have any ionic character. Suppose if we take the case of hydrogen molecule, there no polar covalent bond is present, so it will have a zero ionic character. How do we calculate it? So first of all, talking about the Pauli equation. So Pauling equation says that percentage ionic character can be calculated using the formula 18 into chi a minus chi b, which is raised to the power 1.4. Here chi a is the electronegativity of element A, so it can be anything, and element B is represented by the electronegativity chi b. Remember, chi a must be greater than chi b. Then we have Hanna-Smith equation. Now this equation is much more prominent and much more used. What does it say? It says that percentage ionic character is equals to 16 into chi a minus chi b plus 3.5 into chi a minus chi b whole square. So you will use this formula rather than using the Pauling equation. You will use this Hanna-Smith equation to calculate the percentage ionic character. Now moving on to the next part. Remember, this chi a minus chi b is the electronegativity difference. Moving on to dipole moment. So is there any doubt in that formula? So that formula is very, very important. The second one, questions are asked from that point. So you have to simply put it into the formula to calculate the percentage ionic character if the electronegativity is given there in the question. Now next, what is dipole moment? It is the product of magnitude of charge and the distance separating the centers of positive and negative charge. How can we write it mathematically? So it is written as mu is equals to q in q cross d, where mu is your dipole moment. Remember, dipole moment is a what? It is a having direction. It is having a direction. It is a vector quantity, and it starts from positive and move on to the negative part. Okay, so the direction will be always oriented from positive to negative. Next, if I try to write this in terms of CGS unit, that means in dBi, right? So this is written in the formula of Q into D dBi. So remember, this is the CGS unit of your dipole moment. Now a molecule is said to be polar if this multiplication comes out to be non-zero. Example, NF3 has a lower dipole moment than NH3. That results in the vector pointing towards the lone pair of NH3. But in NF3, it is opposite to that of the lone pair, which cancels the resultant moment. So we will try to understand this in the next slide. So now we will see a comparison of the dipole moment of NH3 and NF3. So listen to this very carefully. So this is the overall structure of NH3 and NF3. How can we see it? We can see that in case of NH3, the dipole moment is directed or pointed from hydrogen onto the nitrogen. Okay. As a result of this, you will see that the dipole moment is adding upwards. So you remember the vector addition. So if these three will add, it will move upwards. And there is one more dipole moment which is occurring due to the lone pair and the nitrogen atom. Now all of these will move to the upward side. But if you take the opposite case of NF3 here, then the dipole moment due to nitrogen and lone pair is pointing upward side, whereas the dipole moment due to nitrogen and fluorine is pointing towards downward side. Means they are cancelling each other in a way. You got my point? So again I am repeating it. Since hydrogen is less electronegative than nitrogen, so electronegative negativity is greater for the nitrogen, the dipole moment will point towards nitrogen, and hence it will move upwards or result in a upward vector of the dipole moment. But in the case of NF3, fluorine is highly electronegative than the nitrogen, and hence it will move away from the nitrogen and towards the fluorine. But the lone pair will always be pointed upward. So since NH3 is pointing upward in both the ways and NF3 is cancelling somewhat of the dipole moment, we will see that NH3 has a greater dipole moment. So if you calculate the resultant dipole moment in NH3, it is 4.90 into 10 to the power minus 30 coulomb meter. Whereas for NF3, it is 0.80 into 10 to the power minus 30 coulomb meter. So you can clearly see a difference between the dipole moment between NH3 and NF3, and NH3 is having a higher dipole moment due to greater charge separation in case of ammonia, which is having a numerical value of 4.90 into 10 to the power minus 30. Is it clear to you? Then if I ask you, what is the net direction in the case of NF3 and NH3? In the case of NH3, all of them are added and the net direction is upwards in the given orientation. Whereas in the case of NF3, 3 fluorine atoms are pointing downward and 1 lone pair is pointing upward. As a result of higher contribution from 3 fluorine atom, the dipole moment will be projected downwards. Okay, so some of them will be cancelled out due to the lone pair and nitrogen, and the resulting will be pointing downwards. So if I want to calculate the percentage ionic character using the dipole moment, then how we can calculate it? So we see our previous formula which used the electronegativity of the elements involved in the bonding to calculate the ionic character. Here we are using the dipole moment. The formula is given as mu observed by mu ionic into 100. So mu observed is what? Which is being calculated experimentally. So it will be given in your question. And mu ionic means what? The one which is calculated using the formula that you saw right now, which is Q into D. Okay. So you will calculate the mu ionic, mu observed will be given in the question, multiplied by 100, and you will get your percentage ionic character with the help of what? With the help of your given dipole moment. Is it clear till now? So you know it that mu ionic is calculated using the formula Q into D. Here Q is always taken as 4.8 into 10 to the power minus 8 ESU. So here we are taking the CGS unit. So therefore, if you keep the distance in centimeter and keep the charge in terms of ESU, then that will result in what? That will result in dBi. Your mu ionic or the dipole moment calculated will come out to be in the dBi units. But if you take the value of Q in terms of SI unit, so in terms of SI unit, this Q will be simply equals to 1.6 into 10 to the power minus 19 coulomb, right? And D is the distance, which is an experimental value again, and that will give you your dipole moment in coulomb per meter. You got my point? So two things are there. If you want to calculate it in terms of what? In terms of CGS unit, you will take the value of Q as 4.8 into 10 to the power minus 8 ASU and distance in terms of centimeter. Then you will get your mu ionic in terms of what? CGS unit, which is dBi. But if you take Q is equals to 1.6 into 10 to the power minus 19 and D you will take it in meter, then you will get your dipole moment in terms of coulomb meter. Any doubt till this point? So these two formulas are very, very important for you. If you have a doubt, you can just comment it here. Okay. Anyone who has a doubt till this point? So again, I am suggesting you that if you want to conquer this inorganic part, then you must focus on 3 chapters. What are those 3 chapters? Chemical bonding and molecular structure. Second is DNF block. And third is your coordination compound. If you still have time, then you can move on to classification of elements and periodicity and properties. Then after you can cover any chapter that you want. Okay. So is it clear to all of you? Any doubt till this point? So anyone, if you have a doubt, you can ask it here without any hesitation. So we have calculated the ionic character using two formulas. The first was Hannay-Smith formula and the second one is using the ionic character. So do you have a doubt till now? Any doubt regarding this part that we have covered so far? Okay, now we shall move forward if you are clear about this part. Next is your partial ionic character of covalent bond. So this thing is summarized in a way. So this result that you are seeing. So how you will determine that whether a given compound is ionic or not. So this is given on the basis of electronegativity difference. So if the electronegativity difference between atom is equals to 1.7, so mu observed is the experimental value which will be given in your question. Okay, it will be the experimental value given in your question. So if the electronegativity difference is between is equals to 1.7, then your bond is 50% ionic and 50% covalent. So you should remember this thing. Okay, now the two formulas that you saw just now, which is used to calculate the percentage ionic character, okay, those formulas are not there in your NCERT, but you will see that there are questions from it. Now how you will tackle that question if you are not covering if you are covering NCERT only, so I will teach that also. But this line that you are seeing right now, which is that the electronegativity difference, if it is equals to 1.7, then the bond will be 50% ionic and 50% covalent. So this line is given exactly in your NCERT, you can look for it. Then if the electronegativity difference is greater than 1.7, then the ionic character is more than 50%. And the third thing, if the electronegativity difference is less than 1.7, then the ionic character is less than 50. So this 1.7 is the borderline. If the difference increases from 1.7 to above, then the ionic character is more than 50%, means it is dominant. If it is less than 1.7, ionic character is less dominant and it is now less than 50%. Now moving on to the Fajans rule. Now this is a very important topic of today's discussion. Questions are asked multiple times from this point of view, okay, or using this concept. It says that the magnitude of covalent character in an ionic compound depend upon the polarizing power. Means how well a cation is able to polarize an ion. What is polarization and why are we referring in terms of cation and ion? Let's see. To understand this, first you should remember that your polarizing power is defined for your cation. And as the size of the cation increases, the polarizing power decreases. So remember the point that I am saying you. What did I say? So your Fajans rule is dependent upon this polarization, and polarizing power is a term related to the cation. If your size of cation is large, then polarizing power will be low. If the size of cation is great, means it is small, then the polarizing power will be high. Now, if I talk about anion, then the anion is easily polarized if it is having a greater size. So basically, this polarization formula or the polarization phenomena is directly proportional to the size of anion and inversely proportional to the size of cation and directly proportional to the charge on anions. Again, I am repeating my thing. So this polarization phenomena is directly proportional to the size and charge of anion, okay, and inversely proportional to the size of cation. Now, for example, if I take the case of NaI and NaCl, you know that in both of these compounds, what will happen? Sodium is common in both of them, but the thing which is varying is your anion. So one is iodine and the other one is chlorine. I said that the polarization phenomena is directly proportional to the size of an ion. You know it very well that iodine has a greater size because it comes a very ahead of this chlorine. Due to this greater size, it has a greater tendency to show the polarization phenomena. Got it? Is it clear to you? As a result of this, it will show more covalent character. So we can just write it in a simple line that the covalent character of any given compound, so just note it down, again I am repeating it, covalent character of any given compound is directly proportional to the size of anion, inversely proportional to the size of cation, and directly proportional to the charge on ions. Will you remember this? It is very important to compare the ionic character or covalent character of two given compounds. What did I say? That your covalent character is directly proportional to the size of an ion, directly proportional to the charge on ions, and inversely proportional to the size of cation. Got it? If it is so, out of the sodium iodide and sodium chloride, which one will have a greater covalent character? Of course, your sodium iodide, because your sodium iodide will have a greater tendency to get polarized and therefore having a greater covalent character. Similarly, if I compare FeCl2 and FeCl3, here both the atoms are same, but the difference is between the charge. FeCl2 is having a +2 charge on the fluorine atom. Okay, so this FeCl2 will have a +2 charge, whereas FeCl3, the iron will have a +3 charge. So the charge is greater in case of FeCl3, and I said that greater is the charge on ions, greater is the covalent character. So this FeCl3 is having a greater covalent character. Is it clear to you? Any doubt in this? So FeCl3 is having a greater covalent character as compared to the FeCl2. Any doubt till this point? So if you have a doubt, you can just post it here. So this is very important for your exams, because questions are asked multiple times to compare the ionic character of different sets of compounds. Now moving on to the next one. Cation with pseudo noble gas configuration has greater polarizing power than the other noble gas configuration cation. Now moving on to one more important topic, which is formal charge. So this is basically the difference between the number of valence electron of the atom in an isolated or free state and the number of electron assigned in the Lewis structure. Now what is the meaning of this? To understand this thing, basically you have to see that what is the increase in the number of valence electron when it is in the free state and when it is in the Lewis or the combined state. So that will give you the amount of formal charge. Next, we have the bond parameter. As I said you, that bond parameter is another important point. How do we calculate the bond parameter? What are bond parameters? Anyone who has an idea about this? What are the types of bond parameters that we have? You can just comment it here. So again, I am repeating my question. What are the bond parameters that we know? So someone is asking what is, okay, pseudo noble gas configuration. So those elements which are having 18 electrons in their valence shell. Okay, suppose we have zinc 2 plus. If you calculate the number of valence electron in zinc 2 plus, it will be 18 rather than 8. So it is seen that such cations are having a greater tendency to show the covalent character. Is it clear? Yes. The bond parameter are bond angle, bond length, and the bond order. Is it clear to you, Niranjana? What is pseudo inert gas configuration? So the one cation which is having 18 electrons in the valence shell, you can take the example of zinc 2 plus, copper plus, silver plus, and then your gold plus. All of them are having a pseudo electronic configuration, pseudo noble electronic configuration. Got it? Yes, we have more bond strength and bond enthalpy. Now, first talking about the bond length. So it is simply the average distance between the center of the nuclei for two bonded atoms in a molecule. Now it depends upon the size of the atom. So greater is the size of the atom, greater is the bond length. Second is hybridization. We will talk about this, steric effect and resonance and etc. Now it is usually seen that the bond length of polar bonds is smaller as compared to the non-polar bonds. So this is very important to remember. So for two identical atoms, one is forming a polar covalent bond, the second one is forming a non-polar covalent bond. It is seen that the polar bond are having a smaller size as compared to the non-polar bonds. So that same atom will have two different bond lengths, and that is very obvious because it is dependent upon the surrounding atoms, that is surrounding your atom you are considering. Next, bond length increases as the size of the atomic orbital increases. So it's very obvious. It will depend upon the size of the given atom that you are dealing with. Next, we have bond enthalpy. So what is bond enthalpy? It is the amount of energy required to break 1 mole of bond of a particular type between two atoms in a gaseous state. Next, bond enthalpy is directly proportional to electronegativity. So if there is a greater electronegativity difference between two elements, then the bond enthalpy will be obviously greater because the electrostatic force of attraction is greater in that case. Then it is inversely proportional to the size of atoms, because if the size of atom will increase, the bond length will increase and the strength of the bond will decrease. So it is easier to break those kind of bonds. And last is inversely proportional to number of lone pairs of electron. It is seen that if your central element has greater number of lone pairs, then it shows a higher repulsion. Now remember, repulsive forces always result in a unstable molecule. So that is the reason they are easily broken, or the bonds are easily broken. What did I say? Again, the number of lone pair increases the repulsion because lone pair shows a higher degree of repulsion. As a result of it, the repulsive forces increases and the molecule gets unstable and it breaks easily by supplying a lesser amount of energy than the expected one. Now moving on to the third bond order with the third bond parameter, which is bond order. It is simply the number of bonds between two atoms in a molecule. As simple as that. For example, if I take the case of, suppose, fluorine molecule formed by two fluorine atoms, then there the bond order will be 1 because one bond is present between the two fluorine atoms. Next, this bond order is directly proportional to the inverse of bond length. So greater is the bond order, shorter is your bond length, because due to higher bond order the bond becomes stronger, and as a result of that the atoms gets closer and the bond length decreases. Next, it is directly proportional to stability. You can take the example of nitrogen, which is the most stable molecule because there are 3 bonds between those two atoms of nitrogen. After that, since bond order is directly proportional to bond strength, therefore a molecule with a species with a greater number of bonds will show a higher bond dissociation enthalpy or bond enthalpy. What is the formula to calculate the bond order? In case of multiple resonance structure present, so bond order is equals to 1 plus number of double bonds divided by number of delocalization position. For example, if you take the case of O3 suppose, then what will happen? There are how many double bonds? 2 double bonds. If you draw the O3 molecule, 2 resonance structures are possible where the double bond can resonate between 2 different sets of oxygen atoms. Now, the number of delocalization position is 2 and the number of double bond is 1. Therefore, the bond order will be 1 plus 1 by 2, which is 1.5. Next, if you take the case of SO4 2 minus, if you draw the structure, then you will see that 2 double bonds are possible and 4 positions are present for the delocalization. Okay, with the 4 oxygen atoms. So that will result in 2 by 4, and 1 plus 2 by 4 is equals to 1.5. Now questions are asked from this point, where you have to calculate the bond order for the species which shows resonating structures. As we can see here for the O3 and the SO4 2 minus, it is not simple as that, because if you simply draw one of the Lewis structure of O3, you can have 2 types of bond order. So between 2 oxygen atoms, we can have a bond order of 2 and 1 both. But since it is distributed, we take an average between those two. Is it clear to you? You can just try it out by drawing the Lewis structure of different molecules that is being given here. So do you have a question? You can post it here. Till this point, do you have a question? Anyone who has a doubt till this point? Okay, so now we will move on to the question. So there are few theory slides left in it. So the fourth bond parameter is your bond angle. So basically it is the angle between the orbitals containing electron pairs around the central atom. Remember, it is for the central atom in a molecule. For example, if we take the case of H2O, so it's very simple. You have to draw the possible Lewis structure or the possible resonance structure. Suppose if I take the case of SO42 minus, 4 structures are possible for the SO42 minus, because 4 oxygens are there. You can make a combination of these 4 oxygen atoms and make 4 different type of SO42 minus. So in case of the first structure, suppose you named your oxygen as 1, 2, 3 and 4. So your double bond can be with 1 and 2. It can be with 1 and 3, or it can be with 1 and 4. Right. So this is the first 3 types, and the fourth type can be between 2 and 4. So as a result of this, multiple structures are possible, and that will result in the total number of delocalization positions. So 4 oxygens means 4 delocalization position. Then 2 oxygens means the number of surrounding atom for the O3. Then again 2 your 2 delocalization position. Now talking about the bond angle, here you can see that a water is having 2 hydrogen atoms, and due to these 2 hydrogen atoms, we can see they are present at a bond angle of 104.5. So where we are seeing the bond angle? With respect to the central atom, which is oxygen. On the left side we have hydrogen, on the right side we have hydrogen, and in between each oxygen and hydrogen we have a electron density. So the distance between these 2 electron densities, that is an orbital, we have a angle spread out known as bond angle, which is 104.5. So do you get what is delocalization positions in this point? Now moving on to the last topic of today, which is regarded to the theory, so which is resonance. So certain molecules like benzene, ozone, nitric acid and many more, so they cannot be represented with the help of single Lewis structure. In that case, multiple Lewis structures are possible, and we call those structures as resonating structures. Now these resonating structures are required to explain all the properties and actual structure, and it is intermediate of these structures. For example, we have carbonate ion and ozone, as we discussed earlier. So these two are capable of showing resonating structures. For example, if you see here ozone, then here ozone can have 2 different resonating structure. Now talking about the delocalization position, one of you asked about it. You can see here that this double bond is firstly between the left side 2 oxygens and on the right side 2 oxygens. So 2 positions are possible. Either it can be between these 2 oxygens, or it can be between these 2 oxygens. Therefore it results in 2 delocalization positions. Is it clear? Varsha Khare, it is clear to you? Is it clear to you? What is delocalization position? Why it is 2 in case of ozone? Okay, now we shall move forward. So resonance is shown only by those molecules which possesses conjugate single and multiple bond. So this last structure that you are seeing, it is used to represent the actual structure, and it is known as the resonance hybrid of the resonating structure. Now this resonance is very important because it imparts stability. It is seen that why is this resonance imparting stability to the molecule? Because greater is the delocalization of electrons. So you can think of it as a weight. So electron, which is a charge, it is a weight for the molecule. Now suppose you are taking your example. If you are given a weight of 10 kgs. Then after some time you will start to feel difficulty carrying it, right? But suppose if you distribute that 10 kg among your friends and you carry only 2 kg, what will happen? You will find it easy to carry it. Similarly, your electrons are kind of burden for the molecule. If it is concentrated on one atom, it will result in instability. But this resonance, what it does, it delocalizes your electrons onto different atoms rather than keeping it to one atom. Therefore, it increases stability. You got my point? So the key idea behind imparting stability due to resonance comes from the delocalization of electrons throughout the molecule onto different atoms of the molecule. Okay. So as I said, the electrons are not localized between a particular atom, and instead of that they are uniformly distributed between certain molecules. It results in a higher stability, but at the same time it results in varying bond length. Means, although we can have a double bond and a single bond, but the bond length is same in all of them. For example, if you take the case of oxygen forming ozone, then the double bond and single bonds, two bond lengths are possible, but it is seen that the actual bond length is not close to double bond or not close to single bond. It is intermediate between those two. Now in that case, how do you calculate each and everything, the bond length on all? You average them. Okay, you average the bond length and then calculate it. Then what is resonance energy? We talked about the resonance hybrid in the previous slide. So resonance hybrid is the one which is representing the actual structure. So you can say that the energy difference between the resonance hybrid or the most stable structure and the most stable structure is known as resonance energy. Again, I am repeating it. So for a given molecule, multiple resonating structures are possible, and among them, which one is the most stable, you can take that and you can subtract it from the energy of the resonance hybrid and you will get your resonance energy. Is it clear to you? Do you have a doubt? So next I will move on to the question. If you have a doubt, you can just post it here. Okay, so just wait for a while. I am coming with questions. So here is your first question. Now this was asked in JEE Mains 2024. So this question is again from the part that we have discussed in the class today, from the theory part, and you can easily do this. So anyone who is willing to give the answer? So this was asked in the recent year, in the year 2024. Apart from this, I will also suggest you to tell me that which of these given species is electron accurate, electron deficient, and having a hypervalency. I will ask each of you to tell everything about these 4 molecules. So this is the latest question of 2024. Anyone who is willing to give the answer to this? It's a very easy one and it was asked in JEE Mains 2024. Yes, so I am seeing answers already. BF3. Anyone else who is willing to give the answer? So please comment the answer in the comment section. So I would expect more answers from you, and it's a recent year question. Which of the following is having an electron deficiency, or which is one is a hypovalent compound? So yes, answer C. Let's see what is the correct answer. Anyone else? Okay, now let's see the answer. So the correct option will be option C. Yes, very good. So electron accurate, A is electron accurate, then PCl5 and SF6 are hypovalent. Let's see if your prediction is correct or not. If I move on to the solution, then we know that the species with an electron count less than 8 in the combined form is named as an electron deficient species. So here, if we start from CCl4, then your carbon tetrachloride can be formed by the electron sharing of 1 each, and this is your overall Lewis structure. Now, since each chlorine is donating 1 electron and your carbon is getting that electron, and 4 were already present in the carbon, so it will result in 8 electrons. Now this is exactly equals to the octet rule that we know. Therefore, your given CCl4 is electron accurate, isn't it? So this is a very easy question from JEE Mains 2024. Now, moving on further. So this was about CCl4, but we were asked about the electron deficient species. So next is PCl5. Your PCl5 can be drawn in this way. So how do you draw the Lewis dot structure again? So 5 chlorine atoms are there, and since chlorine is monovalent in nature, so it will need 1 electron, and hence it will make 1 bond each with each phosphorus atom. Now what will happen? Since 5 chlorines are there and each one is giving 1 electron, total will be how much? 10 electrons. Yes, the phosphorus will have 10 valence electrons. 10 electrons in the valence shell, where we are getting 5 from the phosphorus and 1 each from the 5 chlorine atoms. Now, since this value is greater than 8, so your PCl5 is electron rich or hypervalent species. Got it? Moving on to the next species. So the next species is BF3. Now, if I talk about the BF3 has boron as a central atom, and boron has 3 valence electrons. Now, these 3 valence electrons are shared with 1 fluorine each, forming 3 covalent bond. As a result of this, now the boron, which is the central atom, will have 6 electrons in the valence shell, where 3 are already present in the boron and 1 is coming each from the 3 fluorine atoms, giving a total count of 6. Now this value is of course less than it, and so your molecule is electron deficient molecule. Moving on to the next species. So we already got our answer, but still I would like to deal with each and every molecule that we have here. So in that process, our next molecule is SF6. How do you draw the SF6? Again, if you talk about the sulfur, what category does it belongs to? Anyone? Is it group 16, group 17, or you can tell in terms of name also if it is halogen, chalcogen or anything. So which is the group your sulfur belongs to? So let me give you a hint. It belongs to the same group where your oxygen is there. So what is the group number of this sulfur? We will use these things in the upcoming classes of your classification of elements and periodicity in properties. So anyone? What is the group number of sulfur? To which family does it belong? Alkali, alkaline earth metal, or chalcogen, halogen, noble gas? Yes, it belongs to the chalcogen group, which is group 16. If it is belonging to group 16, that same group where your oxygen belongs to, the number of valence electron will be same. So it is seen in most of the cases, especially in case of S and P block elements, that the number of valence electron is same for all the atom elements belonging to the same group. So since oxygen and sulfur are belonging to the same group, they will have the same number of valence electron, which is 6. Now this 6 valence electron will make a bond with each fluorine atom, and that will count to a total of 12 electrons, 6 from sulfur and 6 from 6 fluorine atoms, one coming from each fluorine atom. Now why your fluorine is making one bond each? Because it is a monovalent element capable of completing its octet by accepting one electron only. Is it clear to you? So it will be a hypervalent compound having electron richness. Any doubt till this point? I hope you're getting my lecture. So you can see how a easy question is asked in your JEE Mains 2024 from your chemical bonding and molecular structure, and that is the reason I am telling you to cover such chapters of inorganic, because if you know it, you will surely answer it. There is no doubt in making mistakes in your calculations and all. But there are some cases where you will see calculational questions from the same chapter. Now let's move on to those types of questions. So here is your next question. Again, it was asked in JEE Main 2018. I said it in the orientation session also. You must look upon to at least 10 sets of previous year questions. Okay. So here is your question. It says that which of the molecule is having no covalent bond? You can see a very easy question has been asked here. The options are KCl, PH3, O2, B2H6, H2SO4. You can just select your correct set from the given 4 set of options. Anyone who is willing to give the answer? So it's a very easy one. So what is the set of molecules which will show the only the ionic bond and not the covalent bond? So you can just answer your correct answer in the comment section. Okay, so I'm already seeing answers. We have B as the answer. Let's see. I would expect more answers from you. Okay, so KCl. Remember students, please join our register free for the website and attempt the DPPs, and you can also visit our recorded lecture on the SATHEE website. There you can get daily DPP problem as well as mock test, which is constituted of several chapters as well. So you will get your complete solution for this upcoming JEE exams. Okay, so let us move on to the correct answer. The correct answer will be C, KCl. So we know that potassium chloride is an ionic compound because they have a very high difference of electronegativity. One is a very highly reactive metal which is having a highly metallic character, whereas your chlorine is a highly non-metal. And if I consider other molecules like PH3, O2, B2H6, H2SO4, all of them have covalent bond in them. So these are the structures of different molecules that we are dealing with. If you look upon PH3, so phosphorus also forms 3 bonds with the hydrogen. Then we have O2 again forming 2 covalent bonds. Then we have BH3 forming covalent bonds between boron and hydrogen. Similarly, you can look it for the H2SO4 and B2H6. So all of them are capable of forming covalent bond, but KCl will have no covalent bond. Is it clear to all of you? Any doubt till this? So this was asked in the 2018. Next question, you have to calculate the percentage ionic character for cesium chloride. Now, the electronegativity difference can be calculated from here because it is given that the electronegativity of cesium is 0.8 and the electronegativity of chlorine is 3.0. If that is the case, then what will be the percentage ionic character? So we have a direct formula. I have made you seen the formula. Just use that to calculate the correct answer, and please comment your correct answer in the comment section. Anyone who is willing to give the answer? So there was a direct formula to calculate this thing. So what is the percentage ionic character? So we have a formula of Hanna-Smith. Remember, I told you not to use the Pauling formula, rather than use the Hanna-Smith formula. Now, you can use that and the correct answer will come out to be 52.14%. How do we calculate it? So it's very simple. To find the percentage ionic character, you will use this formula directly, which is 16 into electronegativity of chlorine minus electronegativity of cesium plus 3.5 into electronegativity of chlorine minus electronegativity of cesium. Remember, always put the one which is having a higher electronegativity on the left hand side, okay? Or else you will get a wrong answer. Now, take the square of the one of those. Further, if you put the values in this, so it will be 16 into 3.0 minus 0.8 plus 3.5 into 3.0 minus 0.8 whole square. Now, if you calculate this further, you will get it as 16 into 2.2 plus 3.5 into 2.2, which is equals to 35.2 plus 16.94 or 52.14%. Is it clear to you? So it's a direct formula based question. You don't have to think that much. Just put the values given in the question directly and you will get your correct answer. Now if I ask you, why is this molecule having such a greater covalent character? Okay. Why is this molecule having such a greater covalent character? Anyone? You can use the Fajans rule to know it. What is the reason behind for a compound like this to have a such greater ionic lesser ionic character? What is the reason behind it? So we talked about the Fajans rule. There we saw that what are the ways we can look upon to measuring the covalent character. So there were four things or four parameters that we have to look upon. So size of cesium should be small for having a greater ionic character. Size of chlorine should be large for should be large. The size of cesium should be large to have a greater ionic character. The size of chlorine should be small to have a greater ionic character. But here if you see, cesium is having a very large size. Now, due to its large size, its covalent character is being decreased. Okay. So that is the reason we are having a ionic compound here. Okay. It is due to the size of the cesium. Now moving on to the next question. You have to decide that which one of the following molecule is polar in nature. Now for this question, I think you have to know about this whisper theory. We will talk about that in the next class. If you already know about it, you can just draw the structure and try to predict which of the following molecule is polar. Okay. If not, if you don't know about this, don't worry. We will talk about this in the upcoming lecture. So which one of the molecule will be polar here? XZF4, IF5, SBF5 or CF4? Anyone who is willing to give the answer? So just try to draw the whisper theory, use the whisper theory and draw the Lewis structure of the following, complete shape of the following molecule. So already answers are coming. C. Let's see what is the correct answer. More answers. So you have to decide that which of the molecule is polar in nature. So the correct answer will be B, which is IF5. Now how? If you draw the Lewis structure, the shape of the IF5, the IF5 becomes polar because of its symmetrical structure. So this is the overall structure of the IF5. Now this IF5 if you see, then it is polar in nature. Why? Why is it polar in nature? Because this fluorine and this fluorine is cancelling the dipole moment. Similarly, this fluorine and this fluorine is cancelling the dipole nature of each other. But if you look upon this fluorine here, this fluorine has no counter fluorine present on the opposite side. Okay. Now there is some part which will be cancelled out due to the lone pair, but that will be not cancelling out the whole effect of the fluorine, and as a result of it, the molecule will be polar in nature due to its unsymmetrical nature. What did I say? That most of the dipole moment is cancelled out due to the opposite dipole moment present here, but this fluorine pointing opposite to that of lone pair will have some dipole moment left in it, and hence it will result in a polar molecule. Got it? Any doubt in this? So can you say that what is the shape of SBF5? Anyone? Do you know what is the shape of SBF5? What is the shape of SBF5 and what is the geometry of SBF5? So two questions are there for you. Is it same or is it different? So this SB, which is antimony, this SB belongs to the 15 group, same as to that of your phosphorus. So therefore it will have 5 electrons in the valence shell. Yes. So its shape will be trigonal bipyramidal, not pentagonal bipyramidal, trigonal bipyramidal, because here for SBF5, if you calculate the steric number, it will come out to be 5, with each is occupied by the bonded pair. So the correct answer will be trigonal bipyramidal, not pentagonal bipyramidal. Now if this is true, then the trigonal bipyramidal, if it is having the same species present on each side, then it will be cancelled out, and as a result of that, you will see that the molecule is non-polar in nature. Okay. So we'll talk about this in much more detail, how this SBF5 is non-polar in nature. So if you know the structure or the geometry, then also you can know about its polar nature easily. Then you can see that how symmetrical that molecule is, due to which it is having a zero dipole moment. Is it clear to all of you? Now moving on to the next question. Which of the following pairs has zero dipole moment? So what will be the answer for this question? Which of the following is having a zero dipole moment? For that again you should have a symmetrical molecule. So we have options CH2, Cl2 and NF3, SiF4 and BF3, PCl3 and ClF, and BF3 and NF3. So what will be the answer for this question? Which one is having a zero dipole moment? Okay. Let's see, the correct answer is SiF4 and BF3. So here, moving on to the solution, if you talk about SiF4, then this will form a symmetrical tetrahedral structure because there are 4 electrons of silicon, because it belongs to the carbon family or the 14th group, and all of these 4 electrons are making 1-1 bond with each fluorine. As a result of this, it will form a symmetrical structure. Okay. Now, if I talk about BF3, again it has 3 valence electrons, and that will result in 1-1 bond with each fluorine. And again, you will see a symmetrical structure for BF3 as well, which is trigonal planar. As a result of its symmetrical nature of SiF4 and BF3, which is symmetrical tetrahedral and symmetrical trigonal planar, it will have a zero dipole moment. Okay. Is it clear to you? So you can just try to draw the structure by yourself. Now, moving on to the next question. So this was asked in JEE Mains 2013. What does it says? So you are given the bond distance in HF, which is 9.17 into 10 to the power minus 11. Dipole moment is given. So this is your observed dipole moment of HF, which is 6.104 into 10 to the power minus 30 centimeter. And you have to calculate the percentage ionic character. So what you can do is you can either calculate it in terms of SI units or it in terms of CGS unit. You can use any of the unit, but it should have the same unit in both the case. Means if you are taking the mu observed in the CGS unit, you must also take the mu calculated in the CGS unit, or if you are taking the mu observed in the SI unit, you should also take the mu calculated in the SI unit. So that should be the condition. Now rest is easy to do, I guess. So mu observed is already given. As I said you in the discussion as well, it will be given in the question, and you can calculate the dipole moment from the data as well, which is Q into D. Then you use the formula mu observed by mu calculated into 100 to calculate the percentage ionic character. So anyone who is willing to answer it? So it's a easy one to do. Okay, so since we are lacking time, I will move forward, but I will suggest you to do this along with me as soon as possible. Now, the correct answer will be D, which is 41.6%. How we'll solve it? So first, you know that ionic character, percentage ionic character is equals to mu observed by mu calculated. Mu observed is already given. You have to calculate the mu calculated, which is equals to charge multiplied with the distance. Here, the charge will be taken as 1.6 into 10 to the power minus 19 coulomb, which is already given in the question, and your distance will be how much? 6.104 into 10 to the power minus 30 centimeter. You have to convert this thing into meter. Okay. Sorry, this will be 9.17 into 10 to the power minus 11 meter, already given in the SI unit, so you don't have to convert it. If you multiply this thing, you will get it as 1.467 into 10 to the power minus 29 coulomb meter. So this you are seeing 6.104 into 10 to the power minus 30. It is already in the SI units. It is in the coulomb meter units. Okay, so don't worry. Sorry for the confusion. This dipole moment of HF is already in the coulomb meter. Now, if you want to calculate it, the percentage ionic character, just put the mu calculated in the denominator and the mu observed, which is given in the question, in the numerator, and multiply it with 100 to get your percentage ionic character as 41.64%. So this was all for today's class. Thank you for joining the session. I hope you enjoyed it.
Hello everyone. So welcome to day 5 of crash course. So today we will cover quadratic equation and inequalities. So trend analysis for chapter quadratic equation and inequality. So according to last 5 year, the chapter weightage is 5.95%. And yearly question distribution. So in the year 2024, total one question come from the topic distance from point. And in the year 2022, again one question come from the topic roots of quadratic equation of average level. Okay. In the same way, in 2021, one question came from the topic graph and wavy curve. And in the year 2020, one question of easy type came from the topic relation between roots and coefficient. In the year 2019, one question came from the topic relation between roots and coefficient of easy type. And in 2017, one question came from the topic relation between roots and coefficient and sum of special series of difficult level. Okay, so this chapter is easy comparing to other chapter, and chapter weightage is also high, that is 5.95%. On average, one question came in each year, so we should focus on this chapter. So in today's class, at first we will understand what is quadratic equation. Okay, next we will learn about nature of roots of a quadratic equation. Then some important result, and after that we will discuss the relation between roots and its coefficient of quadratic equation. After that we will explore what is cubic roots, when two quadratic equation has common roots, what is the condition for that, and finally we will learn about formation of a equation from given roots. Okay, so what is quadratic equation? So if you have any equation such as ax square plus bx plus c is equal to 0, where a is not equal to 0 and the coefficients a, b, c and x belongs to R, it means a, b, c and x, that is roots of this equation, is real number, then this equation ax square plus bx plus c is equal to 0 is called real quadratic equation. Okay, one important thing is a must not equal to 0, because if a is equal to 0, then equation transform to bx plus c is equal to 0, and now degree is 1. So this equation is not a quadratic equation. So for a quadratic equation, a must not equal to 0. Okay, and if all the coefficient and roots, that is x belongs to R, then it is called real quadratic equation. Then how we can find the roots of this equation, this quadratic equation? So roots of the quadratic equation ax square plus bx plus c is equal to 0 is given by x is equal to minus b plus minus root under d by 2a, where this d is known as discriminant and d is calculated by the formula d is equal to b square minus 4ac. Okay, so by using this formula we can easily calculate roots of a given quadratic equation. There is one another method, that is factor method, and by using factor method we can also calculate roots of a quadratic equation. Okay, and if an equation of the form az square plus bz plus c is equal to 0, where a is not equal to 0 for quadratic equation, and the coefficients a, b and c and z, that is root of this quadratic equation, belongs to c, it means they are complex number, then this equation is called complex quadratic equation, and its roots are given by the formula z is equal to minus b plus minus root d by 2a, where this d is discriminant and is calculated by the formula d is equal to b square minus 4ac. Okay, so this is quadratic equation. So what is the form of quadratic equation? Ax square plus bx plus c is equal to 0, where a is not equal to 0, and the formula to calculate its roots is x is equal to minus b plus minus root d by 2a, where d is discriminant and it is calculated by the formula b square minus 4ac. Clear? Okay. Next is nature of roots of quadratic equation. So let's suppose the quadratic equation is ax square plus bx plus c is equal to 0. Okay, and where this coefficient a, b and c are real numbers and a is not equal to 0, then we can relate the nature of roots by the value of discriminant, and discriminant is calculated by the formula b square minus 4ac. So if d is greater than 0, then roots are real and distinct. Okay, so we can relate nature of roots by the value of discriminant. Second is, if d is equal to 0, it means b square minus 4ac is equal to 0, that is b square is equal to 4ac, then roots are real and equal. Okay, third, if d is less than equal to 0, it means b square minus 4ac is less than 0, that is b square less than 4ac. So in this case, the roots for a quadratic equation ax square plus bx plus c is equal to 0 are complex. So they complex root with non-zero imaginary parts. So what is the form of complex number? Like z is equal to x plus iy, the x is real part and y is imaginary part. So roots are complex roots with non-zero imaginary part, that means y is not equal to 0 when discriminant is less than equal to 0. Clear? So that's how we can relate roots, nature of roots with the value of discriminant. Clear? Okay. Now some important result. So there are some important result related to the nature of roots. So suppose we have a quadratic equation ax square plus bx plus c is equal to 0, and one root of quadratic equation is p plus iq, that is a complex root, and where p and q are real number and q is not equal to 0. It means this is a complex root with non-zero imaginary part, and this is a one root of quadratic equation. So its another root, that is second root of this quadratic equation ax square plus bx plus c is equal to 0 is p minus iq. So what is p minus iq? If z is equal to p plus iq is a complex number, then another complex number p minus iq is complex conjugate of p plus iq. So the complex number and its conjugate both are the roots of quadratic equation ax square plus bx plus c is equal to 0. Clear? So complex roots always come in pair when coefficient are real. Second, when the coefficient a, b, c are rational number, that is a, b, c belongs to q, q represent rational number, and p plus root q is an irrational root of a quadratic equation ax square plus bx plus c is equal to 0. So we have a root that is irrational, that is p plus root q. Then the other root is p minus root q. So if you have a root that is irrational root where the coefficients belongs to a rational number and that root is p plus root q, then other root must be p minus root q. Okay. Third, if ABC belongs to Q, that means if coefficients are rational number and D is a perfect square, then this quadratic equation ax square plus bx plus c is equal to 0 has rational root. Why? As it is given, this ABC belongs to rational number and D is a perfect square. So how we can calculate roots of a quadratic equation? The formula is x is equal to minus b plus minus root d by 2a. As d is a perfect square, then the value of root d is a whole number, that is a rational number. And as b is a rational number, so minus b is also a rational number. And when we subtract rational from rational, we again get a rational number. And a is also rational number, so 2a is also a rational number. So rational divided by rational, again a rational number. So whatever we root get, that is by the formula x is equal to minus b plus minus root under b square minus 4ac by 2a is again a rational number. Clear? Here we use the property that whenever we subtract rational from rational, we get a rational number, and when we divide rational from rational, we again get a rational number. Clear? So whenever coefficient belong to a rational number and D is a perfect square, then the quadratic equation must has rational roots. Fourth property is, if A is equal to 1 and BC belongs to integer. So here first leading coefficient of a quadratic equation ax square plus bx plus c is equal to 0 is 1, and b and c, another coefficient b and c are integers. Then, and if roots of this quadratic equation are rational number, then these roots must be integer. This is an important result. So how we get this? So for this, let's understand this theorem, that is rational root theorem, and which state that for a quadratic equation ax square plus bx plus c is equal to 0, any rational root must be a fraction p by q, where p is a factor of the constant term c and q is a factor of a leading coefficient a. Okay, so what is the mean of this theorem? So if we have a quadratic equation ax square plus bx plus c is equal to 0 and it has a rational root, so rational root must be of the form p by q. So according to this theorem, the term p must be, p is a factor of constant term c, okay, and the denominator part of the fraction q is factor of leading coefficient a. Clear? So point 4, so what is point 4? That is, if the quadratic equation, if the leading term a is 1, then its equation implies x square plus bx plus c is equal to 0, where b and c are integer. Okay, and it is given that root of ax square plus bx plus c is equal to 0 are rational number. So according to this theorem, it must be of the form p by q. Okay, and where p is factor of constant term c and q is factor of leading coefficient a, but here leading coefficient is 1. So q is, the factor q must be either plus 1 or minus 1. So we only get p by plus 1 plus minus 1, and p is a factor of constant term c, and c belongs to integer number. So the root must be an integer. Clear? Because root is the type of p by q, where q is a factor either plus 1 minus 1. So p by plus and 1 minus. So we only get integer root. Clear? Very good. So these are the important result for roots. Any doubt? Okay. So what is quadratic roots? So let we have a quadratic equation ax square plus bx plus c is equal to 0, where a is not equal to 0. Okay. Then if you consider alpha and beta as a root of this quadratic equation, then we have a relation between this quadratic root and the coefficient of this quadratic equation, and that relation is when we sum the roots, that is alpha plus beta. So alpha plus beta is equal to minus b by a. B is the second coefficient and a is the leading coefficient. So the sum of root is equal to minus b by a, and another relation is when we product the roots alpha and beta, so alpha into beta is equal to c by a. C is the constant term and a is the leading coefficient. So that is the relation between roots and the coefficient. So this is very important relation for a quadratic equation, that is sum of root is equal to minus b by a and product of root is equal to c by a. Clear? And also if we have roots of quadratic equation alpha and beta, then we can write this quadratic equation as a factor ax square plus bx plus c is equal to a into x minus alpha into x minus beta, where alpha and beta are the roots of the quadratic equation ax square plus bx plus c is equal to 0. Okay. So one important thing is, if you know the coefficient of any quadratic equation, then you can find sum of roots and product of roots with the help of coefficient without finding the roots. Clear? Now some important result. First one is, if the roots of ax square plus bx plus c is equal to 0 are both positive, then the sign of a and c should be like and opposite to sign of b. So what does it means? So we have one quadratic equation, that is x square plus bx plus c is equal to 0, and roots are both positive. So if we consider alpha and beta are two roots of this quadratic equation, then alpha is greater than 0 and beta is greater than 0. Okay. Then the sign of a and c should be like. It means if a is negative, then c is negative. If a is positive, then c is positive. Both sign of both a and c are same and opposite to sign of b. So if a is positive, then b is negative. And if a and c are negative, then b is positive. So how we get this? So by the relation of roots and coefficient, we know that the sum of root alpha plus beta is equal to minus b by a. Clear? And as it is given, the both roots are positive, so alpha is greater than 0 and beta is greater than 0. So alpha plus beta is also greater than 0. So minus b by a is also greater than 0. We have one relation, that is minus b by a is greater than 0. Clear. And product of roots, that is alpha into beta, is equal to c by a by the relation of roots and coefficient. And as alpha is greater than 0, beta is greater than 0, so product is also greater than 0. So alpha into beta is greater than 0. And by the relation, c by a is also greater than 0. Okay. So to satisfy this both condition, that is minus b by a is greater than 0 and c by a is greater than 0, a and c should be have same sign and the sign of b must be opposite with a and c. Okay. Because if let's possible b and a have same sign, then minus b by a, so we get less than 0 because there is a negative sign, negative b by a. So a and b must have opposite sign, then we get greater than 0. And if possible c and a have different sign, then the second condition, that is c by a is greater than 0. If let possible c is negative and a is positive, so we get less than 0. So c and a must have same sign, then it satisfies this both condition. So if the root of quadratic equation are both positive, then sign of a and c should be like and opposite to sign of b. Clear? Any doubt? Okay, I hope this is clear. Now second result is, if the roots of ax square plus bx plus c is equal to 0 are both negative. So if we consider alpha and beta are two roots, so they are both negative, so alpha is less than equal to 0, sorry, less than 0, and beta is less than 0. There is two condition now. Then it imply sign of a, b and c should be like. It means these three all have same sign. If a is negative, then b is negative, c is negative. If anyone is positive, then all of them must be positive. Okay. Now first condition is both are negative, so alpha is less than 0, beta less than 0. Now according to the relation of roots and coefficient, alpha plus beta is equal to minus b by a, and here alpha is less than 0, beta is less than 0, then sum is also less than 0. So from here we get minus b by a is less than 0. There is another condition. And product of roots, that is alpha beta, according to the relation with coefficient, it is equal to c by a. And if both are negative, that is alpha is less than 0 and beta is less than 0, then product will be positive, that is alpha beta greater than 0. And then according to relation with coefficient, c by a greater than 0. Clear? So now we have relation, that is alpha is less than 0, beta less than 0, minus b by a less than 0, and c by a greater than 0. So to satisfy this condition, a, b and c should be like same sign. Okay. So let's suppose c and a have different sign, then this condition is not satisfied. Okay. That is c by a is greater than 0. And if a and b have different sign, then that minus b by a is less than 0 is not satisfied due to this negative. So this condition implies that a, b and c should be have same sign. Okay. Thus all three coefficient a, b and c share the same sign if quadratic equation ax square plus bx plus c is equal to 0 and the roots of this quadratic equation are both negative. Okay, clear? Now part 3. If the roots of ax square plus bx plus c is equal to 0 are reciprocal to each other, then c is equal to a. So now let consider alpha and beta roots. So they are reciprocal to each other. So alpha, we can consider alpha is equal to 1 by beta. Okay. Then what is imply? C is equal to a. So we know that product of root is equal to c by a. So alpha beta is equal to c by a. And if we take alpha is equal to 1 by beta and substitute into this relation, so we get alpha beta is equal to beta into 1 by beta. That is cancel out and we get 1. So 1 is equal to c by a. So from here we get c is equal to a. Okay. So what is the relation? If the roots are reciprocal to each other, then alpha beta is equal to c by a and is equal to 1, and it implies c is equal to a. Okay. Clear? Now part 4. In the equation ax square plus bx plus c is equal to 0, where this a, b, c belongs to R. Okay. Then if a plus b plus c is equal to 0, then the roots are 1 and c by a. Okay. So if we have a quadratic equation, that is ax square plus bx plus c is equal to 0, and this coefficient belongs from a real number, and if there is another condition, that is a plus b plus c is equal to 0, then its roots are 1 and c by a. Okay. And if a minus b plus c is equal to 0, then the roots are minus 1 and minus c by a. So if any quadratic equation satisfy this condition, that is a plus b plus c is equal to 0, then roots are 1 and c by a. And if a minus b plus c is equal to 0, then roots are minus 1 and minus c by a. So for condition 1, that is a plus b plus c is equal to 0, we can easily clearly observe that x is equal to 1 is a root, because if we substitute x is equal to 1 in a quadratic equation, that is ax square plus bx plus c is equal to 0, we get a plus b plus c, and it is given that it is 0. So 1 is a root. And for a second part, if a minus b plus c is equal to 0, so if we take the first root alpha as minus 1 and we substitute into this equation, we get a minus b plus c and that is equal to 0. It is given. So minus 1 is again a root if a minus b plus is equal to 0. So as if alpha is equal to plus minus 1, plus 1 is for first condition and minus 1 is a root for this equation for second condition, and product of two roots is given by alpha beta is equal to plus minus beta. Clear? Because alpha is plus minus 1. So from here the another root is c by a. Okay, for first case, and for second case minus c by a. Now what is cubic equation? So quadratic equation, the form of quadratic equation is ax square plus bx plus c is equal to 0, where the leading coefficient is a and a should not equal to 0, because then the degree of that quadratic equation is 2. So if the degree of an equation is 3 and it is of the form ax cube plus bx square plus cx plus d is equal to 0 and a is not equal to 0, leading coefficient a is not equal to 0, then this is the form of cubic equation, because the degree of this equation is 3. So this is a cubic equation. Now it has 3 roots. So if we consider alpha, beta and gamma are the 3 roots of this cubic equation, then the relation of these roots with the coefficient is first the sum of the roots alpha plus beta plus gamma is equal to minus b by a. Okay. Second, beta into gamma plus gamma into alpha plus alpha into beta is equal to c by a. And if we product all these roots, then alpha beta gamma is equal to minus d by a. So in the case of cubic equation, there are three roots and these three roots are related to coefficient as first equation. When we sum this root, so it is equal to alpha plus beta plus gamma is equal to minus b by a. And when we product the pair and sum, so beta gamma plus gamma alpha plus alpha beta is equal to c by a. And the product of all these three roots alpha beta gamma is equal to minus d by a. Clear? So if we have two quadratic equation, first one is ax square plus bx plus c is equal to 0, and second is a dash x square plus b dash x plus c dash is equal to 0. So when they have same roots, both quadratic equation have two roots. Okay, so when we say they both have same roots, what is the condition for that? So when one root is common in both equation, so there is a specific condition that must be satisfied. What is the condition? The condition is a prime c minus ac prime whole square is equal to bc prime minus b prime c ab prime minus a prime b. Okay, so if the coefficient of this both quadratic equation satisfy this condition, then the both quadratic equation have one root that is common root. Okay, one common root. And when both roots are common, then what is the condition? That is a by a prime is equal to b by b prime is equal to c by c prime. So if you have two quadratic equation and when their coefficients satisfy this condition, that is when we take the ratio of coefficient of x square with the coefficient of x square, so that is a by a prime, and coefficient of b, that is b and b prime, so a by a prime is equal to b by b prime, and constant term, that is equal to c by c prime. And if this condition is satisfied, then both quadratic equation have same root. Clear? So formation of an equation. So if we have roots of an quadratic equation, how we can form the equation of quadratic equation? So let's consider alpha and beta are the roots of a quadratic equation. Then the equation will be of the form x square minus alpha plus beta x plus alpha into beta is equal to 0. So you can easily prove this by the relation of roots and its coefficient. Okay, so whenever you have root alpha and beta, then we can easily write the equation of that quadratic equation. We can form the quadratic equation by using this root, and that form is x square minus alpha plus beta x plus alpha beta. Okay, clear? Any doubt? Okay, so just wait for a moment. Now we'll cover some question based on this. Okay, so now we'll do practice some question based on quadratic equation. Okay. So question number 1. If root under 3x square minus 7x minus 30 plus root under 2x square minus 7x minus 5 is equal to x plus 5, then what will be the value of x? Options are 2, 3, 6 and 5. So in this question, we just need to simplify this equation, that is root under 3x square minus 7x minus 30 plus root under 2x square minus 7x minus 5 is equal to x plus 5, and we get the values of x and we have to choose which value that is satisfy this equation. Okay, so try. Just do the algebraic manipulation, try to square it, squaring both sides, and try to simplify this equation. You get the value of x. So correct answer is option C. So let's see the solution. Okay, so what we have? We have an equation that is root under 3x square minus 7x minus 30 plus root under 2x square minus 7x minus 5 is equal to x plus 5. Okay, so we can write this as root under 3x square minus 7x minus 30 is equal to x plus 5 minus root under 2x square minus 7x minus 5. And to remove these roots, we just squaring both sides. We get 3x square minus 7x minus 30 is equal to, now on the right hand side it become a minus b whole square. So x plus 5 square, that is x square plus 25 plus 10x plus b square. So we get 2x square minus 7x minus 5 minus 2ab. So 2x plus 5 root under 2x square minus 7x minus 5. And when we simplify the above expression, we get minus 10x minus 50 is equal to minus 2x plus 5 root under 2x square minus 7x minus 5. Clear? So we can take common on the left hand side. When you take minus 10 as common, we get x plus 5. and as x plus 5 is not equal to 0. Why? Because x is equal to minus 5 does not satisfy the given equation. We can substitute x in place of given equation, and x is equal to minus 5 does not satisfy the given equation. So x plus 5 is not equal to 0. So we can cancel x plus 5 from the both side, and then we get root under 2x square minus 7x minus 5 is equal to 5. Okay. So just square both side of this equation, we get 2x square minus 7x minus 5 is equal to 25. And when we simplify it, we get 2x square minus 7x minus 30 is equal to 0. And when we solve this, we get x is equal to 6, and that is the value of x. Okay, clear? So second question, the number of solution for equation x square minus 5 mod x plus 6 is equal to 0 is, options are 4, 3, 2, 1. So we have to find number of solution, that is roots, for the equation x square minus 5 mod x plus 6 is equal to 0. So we know that the value of mod x, if mod x is equal to a, then we can write x equal to plus minus a. So the value of mod x depend upon the value of x. Is it less than 0 or greater than 0? Okay. So according to that case, we consider two cases where we get two quadratic equation. First one is x square minus 5x plus 6 is equal to 0. And second as x square minus 5x plus 6 is equal to 0. And for both the quadratic equation, we find the solution. Okay. And then count the distinct solution for the quadratic equation. Okay. So try this. Just consider two cases, when x is greater than 0 and when x is less than 0. Okay, so correct answer is option A. So how we get this? So given equation is x square minus 5 mod x plus 6 is equal to 0. So when x is greater than equal to 0, then mod x is equal to x. So we get x square minus 5x plus 6 is equal to 0. And this is a quadratic equation. We can easily find its solution. Okay. And when x is less than 0, then mod x is equal to minus x. So we get, just replace mod x by minus x, we get x square minus 5 into minus x plus 6 is equal to 0. That is x square plus 5x plus 6 is equal to 0. So now we have two quadratic equation. First one is x square minus 5x plus 6 is equal to 0. And second one is x square plus 5x plus 6 is equal to 0. So now we solve the first one, that is x square minus 5x plus 6 is equal to 0. So we use the factor method. We try to factorize this quadratic equation. So we just replace minus 5x with minus 3x minus 2x. So we get x square minus 3x minus 2x plus 6 is equal to 0. And when we take common and factorize it, we get x minus 3, x minus 2 is equal to 0. And from here, we get two solutions that are roots of this quadratic equation, x square minus 5x plus 6 equal to 0. And these are x equal to 3 and x is equal to 2. Now for second case, when x is less than 0, the quadratic equation is x square plus 5x plus 6 equal to 0. So when we replace 5x with 3x plus 2x, then we get x square plus 3x plus 2x plus 6 is equal to 0 when x is less than 0. And when we factorize it, we get x plus 3 into x plus 2 is equal to 0. And from here, we get the values of roots, that is x equal to minus 3 and x is equal to minus 2. So for this equation, x square minus 5 mod x plus 6 equal to 0, in total we got 4 roots, that is 4 solution. First is x equal to 3, x equal to 2, x equal to minus 3 and x equal to minus 2. So total number of solution are 4. Clear? Now question number 3. The roots of equation mod 2x minus 1 square minus 3 into mod 2x minus 1 plus 2 is equal to 0 are. So we have to find the root of this equation, and the given options are minus 1 by 2, 0, 1 by 2, option B minus 1 by 2, 0, 3 by 2, option C minus 3 by 2, 1 by 2, 0 and 1, and option D minus 1 by 2, 0, 1 and 3 by 2. Okay. So correct answer is option D. So let's solve it. So given equation is mod 2x minus 1 whole square minus 3 mod 2x minus 1 plus 2 is equal to 0. So just consider this mod 2x minus 1 as t. So we get t square minus 3t plus 2 is equal to 0. So this is a quadratic equation. We can find the value of t. So just factorize it. We get t minus 1, t minus 2 is equal to 0. And from here, we get t is equal to 1 and t is equal to 2. Okay. This is a factor method to find the roots of a quadratic equation. So by using the factor method, we get t is equal to 1 and t is equal to 2. So as the value of t is mod 2x minus 1, so when we substitute mod 2x minus 1 is equal to 1, one value of t is 1 and 1 is 2. So mod 2x minus 1 is equal to 1 and mod 2x minus 1 is equal to 2. And we know that if mod x is equal to a, then x is equal to plus minus a. So if mod 2x minus 1 is equal to 1, then 2x minus 1 is equal to plus minus 1 and 2x minus 1 is equal to plus minus 2. So when we solve by taking first as 2x minus 1 is equal to plus 1 and 2x minus 1 is equal to minus 1 and 2x minus 1 is equal to plus 2 and 2x minus 1 is equal to minus 2, we get 4 different values. First x equal to 1, then 0, and from the second equation we get x is equal to 3 by 2 and minus 1 by 2. So these are the 4 roots of the equation mod 2x minus 1 square minus 3 into mod 2x minus 1 plus 2 is equal to 0. Clear? Now question number 4. The product of all the value of x satisfying the equation 5 plus 2 root 6 power x square minus 3 plus 5 minus 2 root 6 x square minus 3 is equal to 10 is options are 4, 6, 8 and 19. Okay. So we have to find all values of x, that is all roots for this equation, and then product of all the roots. Okay. So correct answer is C. So at first we will try to find the roots of this equation, that is 5 plus 2 root 6 power x square minus 3 plus 5 minus 2 root 6 power x square minus 3 is equal to 10. Now there is a relation between 5 plus 2 root 6 and 5 minus 2 root 6. That is, we can write 5 minus 2 root 6 as 1 by 5 plus 2 root 6. Because when you multiply the numerator and denominator by 5 minus 2 root 6, 5 minus 2 root 6, we get 5 minus 2 root 6. So we can write 5 minus 2 root 6 by 1 by 5 plus 2 root 6. Now, if we take the first term 5 plus 2 root 6 power x square minus 3 as t, then we get an equation t first term plus 1 by t is equal to 10. Okay. By using the first equation, that is 5 minus 2 root 6 is equal to 1 by 5 plus 2 root 6, and we just consider 5 plus 2 root 6 power x square minus 3 as t. So we get an equation t plus 1 by t is equal to 10. So when we simplify this, we get t square minus 10t plus 1 is equal to 0. So by using the formula of quadratic equation, how we calculate the root? That is minus b plus minus root under b square minus 4ac by 2a. So by using the formula, t is equal to, we get 5 plus minus 2 root 6. And we can write t is equal to 5 plus 2 root 6 power plus minus 1, because we want to compare the power of t to get the value of x. So as we know that if we consider power 1, that is t is equal to 5 plus 2 root 6, so we get this, and if we consider minus 1, so we get 1 by 5 plus 2 root 6, and that is equal to 5 minus 2 root 6. So we can easily write 5 plus minus 2 root 6 as 5 plus 2 root 6 power plus minus 1. And when we compare the both equation, the power of both equation, we get x square minus 3 is equal to plus minus 1. And from here we get x square is equal to 2 and 4. That is x is equal to minus root 2, minus 2 and 2. So these are the 4 values of x which satisfying the equation. We have to find product of this all value. So when we multiply minus root 2, minus 2 and 2, we get 8. So required product is 8. So correct option is option C. Clear? Now question number 5. So in this question, we have to find the root of the equation. The equation is 2 1 plus I x square minus 4 into 2 minus I x minus 5 minus 3I is equal to 0, where I, the value of I is root number minus 1, which has greater modulus. Okay. So first task is to calculate the root of this equation, and then we have to find which root has greater modulus. So given options are 3 minus 5I by 2, 5 minus 3I by 2, 3 plus I by 2 and 3I plus 1 by 2. Okay. So correct answer is A. So let's solve it. So given equation is 2 into 1 plus I x square minus 4 into 2 minus I x minus 5 minus 3I is equal to 0. So by using the formula of how we calculate the roots of quadratic equation, that is minus b, so value of v is minus 4 into 2 minus I, so we get 4 into 2 minus I, plus minus root under b square minus 4ac by 2a, so we get root under 16 2 minus I square plus 8 into 1 plus I into 5 plus 3I by 4 into 1 plus I. Okay, that is the value of x. So now we just resolve these terms, and when we do simplify this, we get x is equal to minus I 1 plus I or 4 minus I 1 plus I. Okay, so when you simplify this, we get this. Okay, and when we multiply this by its conjugate, that is minus I 1 plus I multiplied by 1 minus I numerator and denominator, we get minus 1 minus I by 2, and 4 minus I by 1 plus I, when you multiply by 1 minus I numerator and denominator, we get 3 minus 5I by 2. So these two numbers, the complex number, are the root of this equation. Okay, we just use the formula minus b plus minus root under b square minus 4ac by 2a and simplify it, we get these two roots. But in the question, we are asked for which root has greater modulus. So now we have to find the modulus of these roots. So how we calculate the modulus of a complex number? So if z is equal to x plus iy is a complex number, then its modulus value is given by root under x square plus y square. So the mod of minus 1 minus I by 2 is equal to root under 1 by 4 plus 1 by 4, that is root under 1 by 2. And for a complex number 3 minus 5I by 2, the mod value is root under 9 by 4 plus 25 by 4, that is root under 17 by 2. And clearly root under 17 by 2 is greater than root under 1 by 2. Hence required root is 3 minus 5I by 2. That is the root which has greater modulus. Okay. Now next question. So we are given an equation x square plus x plus 1 plus 2k x square minus x minus 1 is equal to 0, and it is given that it is a perfect square. Then for how many values of k this will be a perfect square, and given options are 2, 0, 1 and 3. Okay, so we use the condition of perfect square to find for how many values of k this equation is a perfect square. So correct option is option A. So given equation is 1 plus 2k x square plus 1 minus 2k x plus 1 minus 2k is equal to 0. We have an equation x square plus x plus 1 plus 2k x square minus x minus 1 is equal to 0. We just write this equation in the form of ax square plus bx plus c is equal to 0. Okay, by just taking the common of coefficients. Coefficient of x square is 1 plus 2k, coefficient of x is 1 minus 2k, and constant term is 1 minus 2k. Now it is given that the equation is a perfect square, then roots are equal. Okay, and roots are equal only if the discriminant is 0, that is b square minus 4ac is equal to 0. So b is 1 minus 2k, so 1 minus 2k whole square minus 4 into 1 plus 2k into 1 minus 2k is equal to 0. And when we simplify it by just taking common 1 minus 2k, we get 1 minus 2k minus 4 into 1 plus 2k, and when we equate with 0, 1 minus 2k is equal to 0, then k is equal to 1 by 2, and when we equate second term it is equal to 0, we get k is equal to minus 3 by 10. So we have two values of k for which this equation is a perfect square, that is k is equal to 1 by 2 and minus 3 by 10. So total number of values of k are 2. Okay, clear? Now question number 7. If the roots of a square plus b square x square minus 2 into bc plus adx plus c square plus d square is equal to 0 are equal. So roots are equal for this equation, then which option are correct? A by B is equal to C by D, A by C plus B by D is equal to 0, A by D is equal to B by C, A plus B is equal to C plus D. So which relation is correct if this equation has same roots, equal roots? Okay. So correct answer is option C. Since roots are equal for this equation, so discriminant is equal to 0. That is, what is the formula for discriminant? D is equal to B square minus 4AC. So B square is equal to 4AC. So in this quadratic equation, the value of B is 2 minus 2 BC plus AD. So square of this is 2 into BC plus AD whole square. And the value of A is A square plus BC. And the constant term is C square plus D square. So 4AC, so 4 A square plus B square into C square plus D square. Okay. So we just use the condition for equal roots, that is discriminant is 0. And when we simplify this, now we just need to simplify. So just square, we get 4 on the left hand side, we get 4b square c square plus 4a square d square plus 8abcd is equal to, and on the right hand side when we simplify we get 4a square c square plus 4a square d square plus 4b square c square plus 4b square d square. And from here we get 4a square c square plus 4b square d square minus 8abcd is equal to 0. That is 4 into, just take 4 as common in the previous equation, we get a square plus c square plus b square d square minus 2abcd, and that is a expression for ac minus bd whole square. So we get 4 into ac minus bd whole square is equal to 0, and from here we get ac minus bd whole square is equal to 0, and we get ac minus bd is equal to 0. So ac is equal to bd, and then we get, when we simplify we get a by d is equal to b by c. So that is the condition for which the roots of this given equation are equal. Okay, clear? Any doubt? So in today's class, we will cover quadratic equation and some question related to quadratic equation. Okay. I hope session was helpful. Okay then. Thank you.
Hello students, welcome to today's lecture. In today's session, we will discuss about laws of motion. This is theory part 1. Alright, everyone. This is our disclaimer. So, let's see trend analysis of the chapter laws of motion in JEE Mains exam. So, if we talk about the overall weightage according to last 5 years, so it is 3.9%. If we talk about the yearly quotient distribution, so in 2024, question asked from conservation of momentum, circular motion. Total number of questions 2, and if we talk about their difficulty level, so it is average. All right. Similarly, in 2023, question asked from conservation of momentum. Number of questions 1, and their difficulty level EG. In 2022, question asked from motion of connected bodies. Number of questions 1, and their difficulty level average. Similarly, in 2021, question asked from friction, and in 2020, question asked from equilibrium of forces, and their difficulty level average respectively. All right. Now, the topic which we will cover in today's lecture: first, concept of forces, then inertia, then we will study Newton's law of motion, fourth, linear momentum, then second law of motion, then impulse, then we will learn third law of motion, then principle of conservation of linear momentum. All right. And then we will discuss applications of conservation of linear momentum. And last, we will see apparent weight of a body in a lift. Clear, everyone? Yes or no? Are you ready for today's lecture? So let's start with the concept of forces. Now here question arises, what is force? Think about it. So we can say any push or pull that one body exerts on another object is called a force. Basically, force is a vector quantity. What is the meaning of the vector quantity? So we can say a vector quantity has both magnitude and direction. We can categorize it in two ways. We can categorize force in two ways. First, contact force, and the other one, non-contact forces. All right. Firstly, we will talk about the contact force. After that, we will talk about the non-contact force. So, if we talk about the contact force, so it is a force that acts only when two bodies are in contact with each other. For example, tension force, normal reaction, friction. Yes or no? So, these are all examples of contact forces. Then comes non-contact force such as gravitational force, electrostatic force. Alright. So, contact is not required for these, or for instance, weak nuclear force is also an example of non-contact force. So if we talk about the definition, we can say when there is some separation between two bodies. Suppose we have a two body and there is a separation. The gravitational attraction force between two bodies is also a type of non-contact force. Yes or no? This object attracts this type of force, or you can say in non-contact force, the objects attracts the other object towards itself. Or if two charges of the same nature are placed, then one charge will repel other charge. So this is also a type of force where bodies are not in contact. This is also an example of non-contact force. Now look at here for the visualization of contact force and non-contact force. So in this figure, here in this figure, a person exerts a force on a wall, and wall exerts a force on a person. So this is a contact force because person person is directly having directly contact with wall. In second one, look at here, this one, uh, the ball here uh, and the surface of the earth. This one is ball and the surface of the earth, both are separated. So this is a non-contact force because the due to gravity, ball attracts towards the surface of the earth. So this one is the example of the contact force, and second one is the example of non-contact force. So I think the difference between concept of non-contact force and contact force are clear. Yes or no, Niranjana? Contact means directly uh, uh, contact, we can touch. All right. Non-contact like gravitational force. Suppose we have a pen, all right, and when uh, pen is dropped, all right, so it will be uh, under the free fall. All right. So this is the non-contact force because of under the free fall because of gravitational force. So we can say this type of force is non-contact force. Clear, everyone? Niranjana? Varsha Khare? Manisha? Deshmukh? Any doubt? All right. Next is inertia. All right. And this is most important concept for the exam. So if we talk about the inertia, we can say every object possesses a property by which it resists any change in its state. All right. So here if a body is at rest, then it will tend to remain at rest, and if a body is moving along a straight path with constant velocity, then it will tend to continue with along that same path, and this property is called inertia. All right, this property is inertia. Clear? Or we can say inertia of rest. Inertia of rest is tendency of an object to remain its state of rest until an external force acts on it. So look at here in this diagram, the inertia property of cardboard is shown. So let's see, this is very important. Here we have a cardboard, a coin and a glass. A cardboard, a coin and a glass. So a coin is placed on a small piece of paper or a card, and the paper is placed on a top of a glass. Yes or no? So here both the coin and the paper are at rest. Alright. So when you flick the paper quickly with your finger in a horizontal direction, look at figure. A sudden unbalanced force acts only on the paper. The paper moves away immediately. Then what happened? So the coin does not move along with the paper. So it falls straight into the glass. This happens because the coin tries to remain in its original state of rest, showing inertia of rest. Since no horizontal force acts on the coin, so gravity pulls it down into the glass. So this is the condition of the inertia. Clear? Varsha, Niranjana, Simran. All right. So this is the condition of inertia. Now we will discuss about the Newton's law of motion. You know, we have a three Newton's law of motion, known as Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. Firstly, we will discuss about the Newton's first law of motion, or also known as law of inertia. All right. So here, if we talk about the definition, we can say it states that a body continues to be in a of state of rest or of uniform motion along a straight line, unless it is acted upon by some external force the change the state. This is also called law of inertia. All right. So if F equal to 0, in that case B equal to constant or A equal to 0. So let's see an example of Newton's law of motion, Newton's first law of motion. So again, the law of inertia, the example of the law of inertia given by Galileo. So again here, you know, a coin is placed on a small piece of paper and the paper is placed on a top of a glass. All right. So when you flick the paper with your finger in a horizontal direction, a sudden unbalanced force acts only on the paper. The paper moves away immediately. Then what happened? The coin does not move along with the paper. It falls straight into the glass. This happens because the coin tries to remain in the original state of rest, showing inertia of rest. All right. Since no horizontal force acts on the coin, so gravity pulls it down into the glass. All right. So here we conclude that law of inertia and Newton's first law of motion are same. All right. The example of this cardboard and coin and glass is clear. Now we will talk about the linear momentum. It is defined as the total amount of motion of a body, and it is measured as a product of mass of the body and its velocity. So suppose you have a a body and their mass is m, and that body is moving with velocity v. In that case, what will be the momentum? So the momentum of a body of mass m moving with velocity v is p equal to mass into velocity. This is the linear momentum of a body. So here if we talk about the SI unit, so we can say kilogram meter per second. Now again here question arises why kilogram meter per second? Because this is m. M is measured in kilogram, and velocity is measured in meter per second. So unit is kilogram meter per second. And if we talk about the dimensional formula, so we can say ml t inverse. All right, the linear momentum is clear. Now we will discuss second law of motion, and this is very important for the exam. The rate of change of momentum of a body is directly proportional to the applied force. All right, and takes place in the direction in which the force acts. So let's see mathematically. So according to second law, force, the applied force is directly proportional to rate of change of momentum. So dp upon dt is change in momentum. If for removing the proportionality sign, this is the proportionality sign, look at here, this is the proportionality sign. For removing the proportionality sign, there is a constant, and that constant is here k. All right, so f equal to k into dp upon dt. dp upon dt is the moment rate of change of momentum, k is the constant. Clear? So we know the formula of the linear momentum, mass into velocity. So we know dp upon dt, rate of change of momentum, this one. So just put the value of linear momentum, that is mass into velocity. So differentiation of momentum with respect to time, it will be dmv divided by dt. So m is a constant, so take out outside the differentiation term, so it will be dv upon dt. So rate of change of velocity is acceleration, so dp upon dt is equal to mass into acceleration. So we can write f is equal to dp upon dt is equal to m a. Clear? So this is the mass into acceleration. Force is equal to mass into acceleration, and this is the second law of motion. Second law of motion. All right. So in first law, uh, we know inertia of rest is the tendency of an object to remain in its state of rest until an external force acts on it. All right, and an object if moving, then its moving continues until and unless an external force acts on it. And in second law, force is directly proportional to rate of change of linear momentum. Clear? So this is the second law. Now if we talk about the unit, so here we have a two system of unit. First SI unit system, second CGS system. So if we talk about in SI unit of system, the unit is Newton, and in CGS system the unit is dyne. All right. So there is a relation between Newton and dyne, and that relation is what? 1 Newton is equal to 10 raised to the power 5 dyne. And what about the 1 dyne? So to calculate the 1 dyne, we can say 1 Newton divided by 10 raised to the power 4, 10 raised to the power 5. All right, everyone. If this is clear, so thumbs up in the chat box. Any doubt? All right. So look at here in the image, a block of mass m. In this image, a block, this is a block having mass m, and an external force F is acting on it, then what will happen? So the body moving with acceleration A. So according to second law of motion, we can write F is equal to mass into acceleration. All right, mass into acceleration. Clear? The next concept is impulse. All right, and here impulse is a very important concept for the exam. If we talk about the definition, so we can say uh, impulse is the product of force and time interval for which the force acts on a body. It is also equal to the change in momentum of the body. All right, so we can say uh, the formula is I equal to F average into T. All right, defined as product of average force and the time for which the force acts. So if you want to calculate the impulse, so the formula will be I equal to force into time. Force into time. Clear everyone? The another definition. So impulse is also equal to total change in momentum for total change in momentum of body during the impact impulse. So impact for impulse, so we know change in momentum. Change in momentum means final momentum minus initial momentum. So suppose final momentum is P2 and initial momentum is P1. In that case, impulse will be P2 minus P1. Alright, in that case, P2 minus P1 is our impulse. So look at here, we know impulse is equal to change in momentum. So in the given figure here, there are two situations. In the first case, initial momentum P is equal to P1. In the second case, P equal to P2, final momentum. So when a force acts for a short time, the object's momentum changes from 2. The difference between them represents the impulse delivered to the object. Clear? So to calculate the impulse, you have two formulas. First, I equal to force into time and I equal to P2 minus P1, where P2 is the final momentum and P1 is the initial momentum. Clear? Let's see one more example. So a footballer, suppose a footballer kicks a stationary ball. So in that case, what will happen? In that case, ball gains momentum and impulse is given by the kick. All right. Now we will discuss Newton's third law of motion. All right. So what about the first law of motion? Tell me. First law of motion is what? Anyone? Law of inertia. Yes. First law of motion, law of inertia. Second law of motion is force is directly proportional to rate of change of momentum. All right. So what about the third law? So in according to Newton's third law of motion, to every action there is an equal and opposite reaction. All right. So F12 is equal this one F12 is equal to minus of F21. So what is the meaning of F12 or is equal to minus F21? Think about it. Yes, think about it. Everyone. So F12 means force exerted on a body first due to second is equal to force exerted on body second due to first. All right. force on body first due to second is equal to force on body second due to first, but the direction is opposite. Alright. Action and reaction are mutually opposite and acts on two different bodies. Look at here. When a force acts on a body, then the reaction acts normally to the surface of the body. So here a man pushing against a wall, and wall uh, exerts a force F2 on a man. Alright. So there is a action and reaction. Action is F1 and reaction is F2, but the direction is opposite. So F1 equal to minus of F2. If we talk about the another example, think about it. Another examples of third law of motion. Yes, everyone. Niranjana, Varsha, more examples of third law of motion. So we can say when you walk, alright, when you walk, your foot pushes the ground backward. Yes or no? So that is action, and the ground pushes you forward, and that is reaction. Alright, and that forward push helps you to move. One more example. So gun recoil. So when a bullet is fired, the bullet moves forward, that is action, and the gun moves backward, that is reaction. One more example. Jumping off a boat. So when you jump forward from a boat, the boat moves backward. Yes or no? So both forces are equal and opposite. Similarly, rocket propulsion. The gas is expelled downward by the rocket, produce an equal and opposite upward direction force which uh, lifts the rocket. Alright. So this is the third law of motion. Every action there is an equal and opposite reaction. Clear? Now we will discuss about the principle of conservation of linear momentum. You know the formula of the linear momentum? P is equal to mass into velocity. Alright. So it states that uh, if no external force is acting on a system, the momentum of the system remains constant. Or we can say, so, momentum of that system will remain conserved. This is the statement of the principle of conservation of linear momentum. So according to second law of motion, force is equal to rate of change of linear momentum. F is equal to dp upon dt. So if no force is acting, in that case F equal to 0. Yes or no? If F equal to 0, so what will be the dp upon dt? Therefore dp upon dt equal to 0. If dp upon dt equal to 0, so we can say linear momentum equal to constant. This is the principle of conservation of linear momentum. Alright. So before here there are two terms, one m1 v1 initial momentum and m2 v2 final momentum, that is equal to constant. So in the diagram here, conservation of momentum has been explained by taking the example of collision. So suppose we have a two mass m1 and m2. Alright. So this is the condition of before collision. So when m1 and m2 moving towards each other, they will collide. Alright. When they will collide, they exert force on each other. The force exerts on m2 is F, and F m2 by minus F. Minus is shows the opposite direction. After collision, they will separated. So their mass is m1 and their velocity v1, similarly m2 or v2. So before collision, the momentum is m1 v1. After collision, m2 v2. But the total linear momentum is conserved. Clear? Yes or no? So here I have a question for you. So if a body is moving uh, 1 meter per second square, listen carefully. If a body is moving 1 meter per second, all right, 1 meter per second. Here velocity is 1 meter per second and the mass of the body is 10 kg. Mass of the body is 10 kg. So what will be their linear momentum? Think about it and please try to solve this question. Everyone, tell me the answer. What will be the linear momentum? Niranjana, Varsha, Manisha, Nandita. Mass is 10 kg, velocity 1 meter per second. So, what will be the linear momentum? Yes, please try to solve this question. You have some time. All right, 10 kilogram meter per second. All right, good, good Varsha, good Niranjana, good. Anyone? All right. Now, applications of conservation of linear momentum. So first is we can say the propulsion of rockets and jet planes is based on principle of conservation of linear momentum. So upward thrust on the rocket, the formula is F equal to minus u dm up differentiation of m with respect to t. It will be dm upon dt minus mg, and if effect of gravity is neglected, then F is equal to minus u dm upon dt. All right. Instantaneous upward velocity of the rocket v equal to u log m naught upon m minus gt, and neglecting the effect of gravity v equal to u log m naught upon m is equal to 2.303 u log 10 m naught upon m. So these are the formulas, all right, after the use calculation. So you need to learn and for the exam. After neglecting the effect of gravity, instantaneous velocity of rocket is v equal to 2.303 u log 10 m naught upon m, where m naught equal to initial mass of the rocket, including uh, that of the u is equal to initial velocity of the rocket at any time t, m equal to mass of the rocket, and v is the velocity acquired by the rocket, and dm upon dt rate of combustion of fuel. All right. So burnt out speed of the rocket is the speed attained by the rocket when the whole of fuel of the rocket has been burnt. Burnout speed rocket, the formula is vv equal to u log a m naught upon mr equal to 2.303 u log 10 m naught upon mr. Now apparent weight of a body in a lift. So actual weight of a body is mg. Suppose the mg is the actual weight. Here we consider the apparent weight of a man standing in a moving lift. So if lift is accelerating upward with acceleration a, then the apparent weight of the body is r equal to m into g plus a. And if the lift is accelerating downward at the rate of acceleration a, then the apparent weight of the body is r equal to m into g minus a. And if lift is moving upward or downward with constant velocity, then apparent weight of the body is equal to actual weight. All right. So look at here the visualization. If lift is falling freely under the effect of gravity, then it is called weightlessness. So for upward motion, R equal to m uh, into g plus a, and for downward, R equal to m into g minus a. So both the formula for acceleration or deceleration is very important for the exam. So this is there is here you have to need to remember this. All right, everyone, this is clear? Yes or no? Niranjana, Varsha, write in the chat box if yes or thumbs up. I expected from answer from everyone. Yes, clear? Varsha, all right. And one information for you, please rename yourself. This is easier for me for calling. All right. Okay. Thank you. Now we will discuss some practice questions based on these topics. So, are you ready for the practice questions? Yes or no? Everyone. Hello, students. Now we will solve some practice questions based on laws of motion. And this is part 1. This is our disclaimer. So, here we will solve some practice questions based on uh, laws of motion. So, question first, 5 forces inclined at an angle of 72° with respect to each other act on a particle of mass m placed at the origin. four forces are of magnitude F1. Alright, F1, 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 and has a magnitude F2. Find the resultant acceleration of the particle. Alright, so here you have to find out the resultant acceleration of that of the particle. So basically here we need to use the superposition principle and then find its answer. Alright, so the given options: option A, F2 minus F1; option B, 0; option C, F2 plus F1; and option D, F2 minus 4 F1 divided by M. So which one is correct? Think about it. Please try to solve this question. Yes, which one is correct? Tell me. So the correct option for this question is A. Let's see the solution. Here here we have a law by which we sum forces, whether we talk about the triangle law of addition or vector law of parallelogram law of vector addition. So somehow our polygon law of vector addition is also related to it, because the triangle law of vector addition also involves a triangle. Alright, so which is a type of polygon itself. That's why it is also called the polygon law. So here we see that if we have multiple forces, we apply one force after another, then find its resultant. So according to the polygon law, if there are four forces, each with magnitude F1 and acting at an angle of 72 degrees, then their resultant will be along the fifth side of the polygon, but in opposite order. Alright, so look at here. Uh, the forces are acting, this F1, F2, this one F1, then here again F1, here F1, then F1 and F1, and the resultant is this one. This is the resultant. So in the order we are proceeding, the force will be in the opposite order. So the result is that our force will be F1, but the direction will be on this side, on this side. So we have shown this in the diagram. So the force F2 here, resultant force F2 on this side, and the force is F1 on other side. Now so we can write net force on it is F2 is equal to minus F1 in the positive x direction, because if we consider this side as a positive, then the other side direction will negative. Therefore the net force on the particle F2 minus F1. We know the formula of to find the acceleration, that is force upon mass. So here we have a force F2 minus F1 and the mass is m. Alright, so this is our answer. Next one. In this problem, a ball of mass 0.2 kg is thrown vertically upwards by applying a force by hand. So look at here. So here you have uh, a ball on your hand, and when you throw the ball in vertically upward direction with some force, let's see what happens. If the hand moves by 0.2 meter while applying the force, and ball goes up to 2 meter height further. Find the magnitude of the force. So here you have to find out the magnitude of the force, meaning how much force was applied. Alright. So which one is correct? Given options: option A 4 Newton, option B 16 Newton, option C 20 Newton, and option D 22 Newton. So which one is correct? Solve this question. This is very simple question. Yes. Alright. We will cover in the last of the lecture. Alright. Don't worry. Chakradhar, don't worry. So solve this question. Which one is correct? Yes. Which one is correct? Option D, Manpreet Singh. Anyone? Yes. Anyone? Which one is correct? All right. Let's see the solution. So correct option is D. Good. Good, Niranjana and Manpreet. D option is correct. Let's see the solution. So the situation as uh, is shown in the figure. At the initial time, the ball is at P. All right. So then under the action of force exerted by hand. So it means P to A. P to A, from P to A, let the acceleration of the ball during P to A is A meter per second. Alright. Assume to be constant in an upward direction, and velocity of ball A is V meter per second. Alright. So here the distance is 0.2 meter from P to A, and A to B is 2 meter. So remember this for uh, the reference. Then for PA, here we use the equation of motion, V square equal to U square plus 2AS. So just put the values in the formula. So V square equal to 0 square plus 2A into 0.2. So for AB, it will be 0 equal to V square minus 2 into G into 2. Alright, just solve the equation and you will be get V square equal to 2g into 2. Alright. So from the above equation, A equal to uh, 10g. Alright. So now here A equal to 10g. So then for PA from FBD, F equal to mg. So we can say F minus mg equal to ma, total force. F is the force exerted by hand on the ball. So F equal to m into g plus a. So just put the values. 0.2 into 11g is equal to 22 Newton. Alright. So this is the correct answer. Alright. Now a player catches a cricket ball of mass 150 gram moving at a rate of 20 meter per second. If the catching process is completed in 0.1 second, the force of the blow exerted by the ball on the hand of the player is equal to what? Given options: option A 150 Newton, option B 3 Newton, option C 30 Newton, and option D 300 Newton. So which option is correct? Yes, please solve this question. Everyone. Which one is correct? Niranjana, Chakradhar, Manpreet? Anyone? Yeah, please try to solve. Yes. How many of you dreamed of getting into an IIT? Tell me honestly. All right. Let's see the solution. So correct option is C. This is this question is based on impulse momentum theorem. All right. So if we want to write this using the impulse momentum theorem, the same thing also emerges from there, that F into delta t is equal to change in momentum, mode of change in momentum. Alright, here we are taking its magnitude, not using the minus sign. So mode of F into delta t is equal to mode of change in momentum. So just put the values. So F into delta t. So here delta t is 0.1 second, or change in momentum, final momentum minus initial momentum. So Pf minus Pi. So as the ball will stop after catching, so here initial momentum Pi equal to mvi equal to 0.15 into 20, so it will be 3. So ball will stop after catching, so final momentum is what? 0. So Pf equal to 0. So according to impulse momentum theorem, F into delta t, that is 0.3, equal to change in momentum. So we have a change in momentum, final momentum minus initial momentum, mode of final momentum minus initial momentum, that is 3 here. So F into 0.1 equal to 3. So solving this term, you will be get F equal to 30 Newton. Alright, Niranjana, 30 Newton. Clear? C option is correct. Not 300, 30 Newton. Alright. Next one. A ball of mass m is thrown vertically upwards with a velocity v. If air exerts an average resisting force F, the velocity with which the ball returns to the thrower is what? Given options. Option A, V into root mg divided by mg plus F. Option B, V into under root F divided by mg plus F. Option C, V into under root mg minus F divided by mg plus F. And option D, V into under root mg plus F divided by mg. So here we need to keep this in mind, that uh, we have to find out the velocity. Alright. So which option is correct? Please try to solve this question, everyone. Yes, which one is correct? Manpreet? So correct option is C. So now let's discuss its solution. Let's assume the object is moving in upward direction with velocity v. If we throw it, it will go upwards. So we gave it some velocity due to which it went up. Now when it is going upwards, two forces will act on it. Uh, Two forces will act on it downwards. So one is the ball's mg, and other is the frictional force F. So both will be downwards. So retarding force mg plus F. This means the retarding force will be here mg plus F. So retardation acceleration A is equal to mg plus F divided by m. So if we have given that it an initial velocity v, the question states that if we throw vertically upwards with velocity v, so its initial velocity v and we have acceleration, it means there will be retardation in this direction. So we will call this retardation because it is acting in the direction of opposite to the motion. So distance s is equal to v square divided by 2a. So it will be v square m divided by 2 into mg plus f. Alright. So the distance is traveled by object when it went upwards. Now what happens after that? The object will start falling downwards. So here we need to tell with what velocity the ball will return to the thrower. So we know the distance is travel upwards. Once it has reached the top, it will start falling downwards again. At, at that time, mg will accelerate it because mg is applying a downward force, and F will show retardation on it as shown in the diagram. So this means if it is going downwards, its magnitude will be greater than compared to this case. So we can write mg minus F equal to ma prime. All right. So a prime equal to mg minus F divided by m. So distance is v prime square divided by 2a prime. So just put the values, you will get v prime square m divided by 2 into mg minus F. As s is equal to s prime, so v prime equal to v into under root mg minus F divided by mg plus F. A block of mass 200 gram is moving with a velocity of 5 meter per second along the positive x direction. At what time t equal to 0? When the body is at x is equal to 0. A constant force 0.4 Newton is directed along the negative x direction is applied on the body for 10 seconds. What is the position x of the body at t equal to 2.5 seconds? So here you have to find out the position. Given options, option A x is equal to 6.75 meter, x is equal to option B x is equal to 6.25 meter, option C x is equal to 6 meter, and option D x is equal to 6.50 meter. So which one is correct? Tell me, everyone. You have some time to solve this question. Yes. Anyone? Manpreet? Niranjana? Nandita? So correct option is B. So now let's look at its solution. So here uh, a block that is moving with speed 5 meter per second along positive x direction. So the force being applied here can be written as F equal to minus 0.4 Newton along negative x direction, because its direction is in negative x direction. And its mass is given as 200 grams. So in kilogram it will be 0.2 kg. So if we calculate the acceleration generated by this force in this direction, so it will be a equal to F by m. So we know the value of F and we know the value of m. So just put the value, you will be get a equal to minus 2 meter per second square. The negative sign showing the retardation. So the position of the object at time t is given by x is equal to x naught plus ut plus half at square. So when x naught becomes 0 at t equal to 0, then this equation will be x is equal to ut plus half at square. Now we will put 2.5 in the place of t here, and you will be here. The answer will be x is equal to 5 into 2.5 plus 1 by 2 into minus 2 into 2.5 whole square. So solving this, you will be get x is equal to 6.25 meter. All right, this is clear. These questions are booster for your preparation. Work as a booster. Anyone? Two trains A and B are running in the same direction on parallel tracks, such that A is faster than B. If packets of equal weight are exchanged between the two, then which option is correct? Option A will be retarded but B will be accelerated. Option B, A will be accelerated but B will be retarded. Option C, there will not be any change in the velocity of A but B will be accelerated. Option D, there will not be any change in the velocity of B but A will be accelerated. So think about it and tell me which option is correct. Yes, think about it, this question. Anyone? If you want to get into IIT, you have to work for it. So there is a no shortcut to success. All right. So please try to solve this question. Yes. Let's see the solution. So correct option is A. So here initially the momentum of the packet in train A is more than in train B. Why? When packets are exchanged, the packet reaching train A being of lower momentum will retard the train A, but packet reaching train B being of the higher momentum will accelerate B. Alright, so here we can say initially the momentum of packet from train A is greater than that of a packet from train B. Due to this, train B's momentum will decrease in this direction, and the packets that comes from the direction will have more momentum. So due to this, the change that will occur here is that the packet we are delivering to A has less momentum. Because of this, train A will retarded, whereas the packet going from A to B has higher momentum in A compared to B initially. Now, when we exchange the packet here, its momentum will be transferred, due to which B will accelerate. That is, suppose two trains are moving like this. So a packets is exchanged, then V's velocity is less and A's velocity is more, so the packet's momentum will also be more and the other's momentum will be less. Now a packet was given from train A to B, due to which V's momentum slightly increased. All right, and when we gave a packet from B to A, A's momentum decreased, due to which B will accelerate and A will retard it. All right, so A option is correct. Next one. Which of the four arrangements in the figure correctly shows the vector addition of two forces F1 and F2 to yield the third force F3? So which one is correct? Yes, think about it. This is very simple. A, B, C or D? Students, which one is correct? Yes. So correct option is A and C. So now let's begin to solve this problem. So we have a parallelogram law of vector addition. All right. So here F1 and F2 are given, due to which we obtained F3. And if we look at both diagrams A and C, here F1 and F2 uh, will also get F3 here. Alright. So in this manner, the correct option for this question will be A and C both. Alright. Yes. Good. Good, Niranjana. Your answer is correct. Good. Very good. A string of negligible mass going over a clamped pulley of mass m supports a block of mass m, as shown in the figure. The force on the pulley by the clamp is given by what? Given options: option A, root 2 mg; option B, under root m plus m whole square plus m square into g; option C, 2 mg; and option D, under root m plus m whole square into g. So which option is correct? Everyone, please try to solve this question. So correct option is B. So force on the pulley by the clamp is equal to resultant of force m plus m into g acting along horizontally and mg acting vertically downwards. So the force exerted on this pulley due to the clamp will be equal to the resultant force of these two masses. Okay. So what will we do now here? So look, force will be applied on this direction. All right. So tension, here this one is tension, will be created in the string. Due to this, uh, in this case, mg, here vertically downward, and for this small m, the force is to it, force due to its mass will also be mg. So to support the clamp, we need to resultant of these two forces, meaning the clamp will support in the opposite direction. Because of the resultant, these two will emerge here. So the resultant of these two will emerge, all right, and the support, uh, we can say force equal to it, will have to applied on the clamp in the opposite direction. So F equal to under root mg plus mg whole square plus mg square. So we will get the resultant force. This is what the clamp is supporting, and the supporting means that the force being applied will be in the opposite direction. Alright, so in simply we can say F equal to under root m plus m whole square plus m square into g. Alright, so this is homework for you. A bullet is fired from a gun. The force on the bullet is given by F equal to 600 minus 2 into 10 raised to the power 5 t, where F is in Newton and t in second. The force on the bullet becomes 0 as soon as it leaves the barrel. What is the average impulse imparted to the bullet? So here you have to find out the impulse. Alright, this is the homework for you. Alright, everyone? Yes or no? Anyone? Who all have completed their homework? Alright, that's all for the today. So the correct option is C. So we have a force F is equal to 600 minus 2 into 10 raised to the uh, power 5t. So at t equal to 0, F equal to 600 Newton. So according to question, F equal to 0 on the leaving the barrel. So when we put the value in the above equation, you will be get t equal to 3 into 10 raised to the power minus 3 second. This is the time spent by the bullet in the barrel. So according to force, average force, so we can say 600 plus 0 divided by 2 equal to 300 Newton. So average impulse imparted equal to F into T. So just put the values, you will be get 0.9 Newton second. Alright, everyone. So that's all for the today. Thank you for attention. Thank you.